So this is being prepared. So one moment until we start, and then we will do the usual business for the user group. Cool. So we are live. Hello, everybody, and welcome once more. All right, and I muted my YouTube channel, so there's no coupling. I hope it didn't bother anybody. So welcome everybody. This day is really, really exciting. It's been a pleasure organizing this event together with Stefan, which we planned that since last year. So it's a pretty exciting event that has been in the cooking, and lately it has gotten bigger than we expected. Thanks to Stefan bringing Steve. And then we organized a ATA panel, which I hope it will be very interesting. So let me share the screen and share sound as well. All right. So can you see the screen?
Yep.
Perfect. So welcome to today's event, a pretty exciting event about source generation. If you are excited about source generation, this is the day. Today we have Steve Collins with a source generation game and Stefan Paul's Never Send a Human to Do a Machine's Job. Sounds like Blade Runner. And then we have an incredible experts panel at the end, which both of the speakers and two more experts to add. But first, let's give thanks to our sponsors. And today we have one announcement. Recently, we got M&S Software Engineering as a gold sponsor. So thank you so much. And concretely, thanks to Guido Jurg. He was the person. And yeah, we're also really happy. We are renewing and pushing our sponsorship again, as we are no longer in online mode. We are going to organize in-person events, real events, and we will try as well to keep them mix, so a hybrid of in-person and online as well, so people that are not from Zurich can also attend to them. That said, thank you to Vivao offering solutions for texture, for being our gold sponsors for all this time. Also to our usual locations, Impact Hub Zurich, Stanford Group, and to our partners, Azure Zurich User Group, .NET Central User Group, .NET Day Switzerland, and Swiss Angular. Thank you so much. But apart from that, who are we? Well, me, you know me, you see me almost every session. Sorry about that. We have Powell, we have Michael, Nigel, Laurent, Fabian, Mark Muller. Probably you know all them. Most of them are seasoned speakers and community contributors and fantastic persons, I would say. What do? We organize events from developers to developers. We share knowledge. We try to also share passion and create passion and excitement about technology. I hope you are excited about today. We usually have networking included. We usually stay a bit longer after the session. Today it's going to be a long session, so it depends on the mood. And usually there is some networking. And whenever we were in person, we had beer and pizza. But we are going to have that soon. So what can you do? You can follow us on Twitter, in .NET Zurich and LinkedIn, join our Meta group. Probably you have, otherwise you would not be here. Can you silence yourself, please? I think there is a bit of noise in the background. You can also tell your peers, help us grow, propose content and speakers. And you have our Sessionize link here on the slide, sessionize.com/.NET Zurich. See our website. And today is about .NET source generation with C#. If you're curious, this is, I think, a great session to get introduced to it. We'll have the source generation game with Steve Collins. Then we will jump to a Roslyn source generation with Never Send a Human to Do Machine Job, which is kind of a continuation. So they have been talking and synchronizing the sessions. So one is kind of an introduction, the other is going deeper. And at the end, we will have a Ask the Experts panel with Steve Collins, Stefan Pauls, Thomas Claudius Huber, and Michael Stipe. That said, on the 8th of November, we will have an in-person live watch party for the .NET conference. So if you go to our meetup page, you can already register. It is, as always, free, and we would love to see you there in person. And let's welcome our speakers. Stefan, flash over polls. Welcome. He's a C# coder, test-driven developer, source generator, expert, speaker, and he has the most weird Twitter handle I have ever seen.
Damn it.
Yes.
Naming is hard. Never going to live that one down.
That's it. This session is mostly thanks to him. I met him last year when we both were speaking in NDC Oslo. Don't know why they got me, but yeah, that happened. It was pretty cool. And suddenly we talk about we should organize a source generation event. And yeah, here we are. Things happen. And we have Steve Collins, software architect and developer from the UK here. He's also user group leader on mk.net. You have to tell us what means MK. I'm curious.
It stands for Milton Keynes, which is a town in the UK.
Oh, cool. Nice. I would never have expected that. Usually it's about the technology. No, not really. But MK, it's quite niche, right? If you don't write it completely, like for example, in our case, Zurich, we put set age. People outside would not know. Steve is also a speaker. And as you can see in our logo of the event, he is also a very good designer. Thanks for making that, Steve.
That's okay.
Yeah, there you have his Twitter handle and his LinkedIn if you want to be in contact. And also we have two more persons today. We have Thomas Claudius Huber. He's a software developer. He's a source, Microsoft MVP. He's a book and Pluralsight author, husband, father of three, runner, skateboarder, and weightlifter. Yeah. Apart from that, he's even more. So I don't know, Thomas, where you take time from doing that, right? So he's a very active person. He's also super positive, one of the most positive persons I've ever met in the community. And he's also a great person, which is sometimes it's correlated, sometimes it's not. So he does contribute to society and inclusivity doing, I would say, incredible social actions. Like, for example, this that he posted last week. So he is collaborating with a local soccer group in which is focusing supporting inclusivity. So yeah, that's really, really amazing. Thanks for doing that.
Thank you, Josie. Hi, everyone. Great to meet you. And I'm looking forward to the evening with all you.
Yeah, it's a pleasure. He's also open source lover and contributor, if I did not say that. And yeah, we got to Michael. I don't know if he's on the talk today, but are you here, Michael? Or you're still making food for your kids? Probably not, still around. So this logo is from Hot Chocolate. He's passionate about technology and development. He's recently became a GraphQL Foundation, I think TSC member, Microsoft MVP, author of Hot Chocolate, conference speaker, YouTuber. Well, what is he not, right? I have the chance to work with him, and I can tell that he's more outside the office in conferences than in the office. And lately, he's has a second-time job, which is a tour on source generate. No, sorry, and he's what's the name? Yeah, he has a workshop. He's been doing like a tour of a permanent NDC workshop, basically on all different NDCs, and also like you, Thomas, he's father of three, husband, and he's a real nice and funny guy when he has time for a beer. But well, that said, I give the stage to you, Stefan. Stefan? Sorry, Steve.
Yeah, okay. Let me just move my screens around and start sharing my screen.
Perfect.
There's screen share on that one. Oh, okay, share. Hopefully you can see the logo.
We do.
Excellent. Okay, right. Okay, let me get my clicker working. Right, so hello everyone. Thank you for coming along this afternoon, this evening, to our source generator special. Thank you to Stefan for asking me to join in on the back of his talk. Before I start, a quick introduction. Already, as you gather by now, my name's Steve Collins. I'm a contract developer architect based in West Sussex in the UK. As Steve Collins is quite a common name, I use the alias of Steve Talks Code for Twitter and my blog. As already mentioned, I run the Milton Keynes.net user group in the UK, which is online still. So if you look it up on Meetup, you're more than welcome to join us. So I've got quite a few links in this talk, most of which are in a GitHub gist. So I've created this bit.ly link and there's a QR code there, which I'll keep at the top of most slides. So if you want to sort of look into some of the links a bit later, you can just follow that link. So later, Stefan's going to be doing a deep dive into the Roslyn source code generators that were introduced with .NET 5. But whilst Roslyn tooling to do this is relatively new, what was coming up to a couple of years now, code generation has been around for many years in one form or another. So with that in mind, this talk looks back over the last, I've got the white hair to prove it, the last 30 years, the many ways that we've tried to do this. Hopefully this journey will provide some context as to why everyone on the panel today loves .NET source code generators. So with that, let's get started. Before we get ahead of ourselves, let's take a step back. What is source code generation? Now, rather than start with the definition of what source code generation is, it might be better to ask what, for the purpose of this talk, it isn't. So for me, server-side web applications that create HTML, CSS, and JavaScript, it is generating code, but it's not really source code generation. I like to think of that as code rendering. As the code created, you don't execute it at the place you generate it. You send it down over the wire down to a browser, web browser to execute, and that's where it passes and executed. Things like TypeScript and Blazor are a bit of a sort of grey area, given that they do generate code, but really what they're doing is converting code from one language to another, be it JavaScript or WebAssembly. So again, I'm not really going to talk about those today. Next, we have things that dynamically generate code in memory and execute it immediately. So in .NET Framework and the earlier versions of .NET Core, things like JSON serializers and regular expressions have relied on using reflection to build code on the fly. But you never actually see the source code that they emit. It's all sort of hidden away from you in memory. Now, the problem with these is that you pay a performance penalty as this code is generated at runtime rather than as part of the compilation process. So as your application starts up or when it first hits those things, it's going to go and do some JIT compilation on the fly. So not only are you paying a performance price while reflection scans over your code to actually do those things, when it executes, it's doing stuff on the fly, so you're paying that performance price. However, since I originally did this talk when .NET 5 first came out and it was all nice and new and shiny, Microsoft have been busy sprinkling source code generator goodness over both JSON serializers and in .NET 7, we'll see it in regex. So I'll talk about those a bit later. So if those things don't count as source code generation, what does? So for this talk, it's mainly about code that creates actual source code at design time when you're actually programming it, that then gets baked into your final compiled code as if you'd written it yourself. That's where we have .NET source code generators that Stefan's going to do a deep dive into later, but I'm going to sort of introduce as we get towards the end of this talk. But before we get into that, it's useful to look back at the many ways we've tried to generate code over the years. So if you indulge this old man with the white hair, I want to take you on a trip down memory lane with my journey with source code generators. And to do that, we need to get in the time machine and go back in time to 1988. That's where my story with source code generators begins. Back in 1988, is before I had PCs, I was programming one of these, the Sinclair ZX Spectrum. To give this some context, this was long before we had GitHub. In fact, it was long before we had the World Wide Web, full stop. So if you wanted to share code with other people, you had to sort of go through the painful process of sending your program off in a magazine to get it published. So here we have an example of a typical listing that you would find in one of those magazines. These were mostly written in BASIC, and which was built into most home computers at the time. It was built into the ROM, and your actual, instead of having a disk operating system or Windows, just to load a game, you had to program in BASIC just to say, load this program. You even got a program manual out of the box as well. Now, the problem with basic programs on these machines was that they could be really slow because they ran through an interpreter. They weren't compiled. If you wanted to get some performance, you had to get down to the bare metal programming with Z80 machine code in the case of the Spectrum. So, given that Pluralsight and YouTube tutorials were far away in the future, this meant having to read books like these to learn assembly language. And in turn, you needed an assembler to turn your code into the raw bytes that will run on the machine, basically what Roslyn does as a compiler now. So here we have the first 35 bytes of a program, and as you can see, the listing is quite verbose. That meant that these assemblies were way too long to print in a magazine. The print cost of printing pages and pages and pages of assembly listing, they weren't going to do that. So you needed some other way of sharing machine code. So given that the core bits that you want to share are the actual bytes that get generated from the assembler, that's what we need to give to people. So if I pivot those into some lines of hex, magazines could then print machine code listings as data statements. The hex dumps would come at the end of a hex loader program that would read all these strings into memory as bytes, and it would have those sort of decimal checksums at the end to make sure that you hadn't actually typed it in incorrectly. More importantly, what on earth has this got to do with source code generation, you may be asking? This is why 1988 is a landmark year for me. I saw this program in a magazine called George Sinclair that was in the UK, the Data Banker. This program does exactly what I've just described. It scans through memory and then creates a hex dump. Now, this was the first time I'd seen a program that could write lines of code by itself, a code generator. But what really got my attention was that the feature editor mentioned that he thought it could have been written in machine code. Now, I'd been learning machine code for a couple of years by this point. So that was the gauntlet thrown down. And in a burst of youthful naivety, I thought, oh, I'll have a go at that. But as with all these things, what seemed like an easy task turned out to be a lot harder than I thought it was going to be. Now, you may be thinking, yeah, surely that's quite easy. You read some memory, convert it to byte values, write it out as strings. But it was a lot harder than that. Remember, this was before we had sort of things like sort of Visual Studio, what have you. This was because the Spectrum was unusual in the way it handled basic commands. Instead of typing character by character, as you would now, sort of in Visual Studio or VS Code or even Notepad, those clever people at Sinclair thought it would help people to learn the basic programming language by printing the commands on the keyboard and assigning each keyword to a key. But as there were too many keywords to assign to one per key, you had all these combinations, so you had to use all sorts of different shift keys to get to the different keywords. So if I turn on a vintage 1980s TV and boot up a ZX Spectrum, you'll see that the cursor keeps flashing with different K, E, Cs. These were the different modes you had to use on the shift keys to get to the different keywords. Now on the Spectrum, the 90-odd keywords to the basic language, which feels incredibly small compared to, say, modern C#, as each keyword was assigned a key combination, they were stored as tokens in memory rather than plain ASCII. And that's a significant thing that we'll come on to later. This meant that my program had to emulate all these statements being typed in via the keyboard because you weren't just doing straight ASCII or Unicode text. Once you got it into memory, then it could be interpreted and saved. Luckily, the book on the left, told me how to work with the keyboard processor and how the basic parser worked. A bit like going to the Roslyn GitHub repo now and seeing how Roslyn does its compilation. So after 4 months, it was finally complete. And that triggered a recursion of using the program to write itself as data statements so that other people could type it in so that they could run it against their programs, so that they could print out their programs and send them off to magazines. All I can say is, thank goodness we've got GitHub to share code these days. So if I scroll down and then do a bit of a zoom out, at the top, we have a hex loader program written in BASIC that would then read those data statements and load those bytes into memory as machine code that could then be executed. So I wrote a nice covering letter saying, please, please, please print my program. Thank you very much. And sent it off on a cassette with a listing. And a few months later, in July 89, it was published in Your Sinclair. Woo! Fame at last. If I zoom in on here, this did my ego a lot of good. The single most revolutionary and visually astounding routine in computer programming history. modesty prevails from acknowledging that. I think the feature editor got a bit carried away. Before we move on, let's consider some of the lessons that I learned when I was sort of doing that about the rules of source code generation. To generate some source code, you need to start with some source input. Now, in my case, it was the memory, but generally it's some kind of metadata. Next, you need to understand the syntax of the language you were generating code for. So in this case, it was the basic language on the spectrum. Lastly, you need to understand how you can actually have that code generated and get it to run, be it an interpreter like on the spectrum or through a compiler like Roslyn. Skipping forward to around 1994, I started using VB3, which felt light years from Sinclair Basic. Hold on, my clicker's gone. Oh, there it goes. This was the first time I had an IDE. I mean, we're so used to things like Visual Studio now doing 101 things for us, but this was the first time I saw an IDE that would start to actually generate some code for me. Now, admitted, it was pretty basic. All it was doing was you were dragging some controls onto the Windows form surface, and it was just generating stubs of code that you could then put a bit of code behind. Mouse-driven rapid application development. So that was fairly primitive, but it was light years ahead of what I'd been doing on things like the Spectrum and then the Atari ST. So for about 8 years, I used various versions of VB, started with 16-bit Windows applications. That was in the VB3 days, then on to 32-bit in VB4 and VB5. But by the time we got to VB6, we were writing enterprise applications. These worked on intranets and this newfangled thing called the internet. Now, when I say enterprise, back in those days, enterprise just really meant reading and writing to a database. And this was when 3-tier architectures was considered best practice. So if you read stuff from Microsoft back then, it would say, yes, you've got a presentation layer, you've got a business logic layer, and you've got a database layer. But back then, database administrators were absolutely horrified at the thought of letting applications use SQL directly against the database. So instead, everything needed to be done via a stored procedure. So given how boring it is to write CRUD boilerplate, we started using tools that could start reading the database schemas and create not only stored procedures, but the VB code that could call them. So this was the next sort of level of source code generation I was moving into, sort of using things to read database metadata and use templates to generate code that I could then actually copy and paste into my VB programs. But time marches on, and by 2002, we were introduced to the new world of .NET. Now, at the time of the launch of .NET, Microsoft's big pitch was that the internet was the big thing, and the new platform was created so that developers could be productive in all these new web technologies, hence .NET, because, you know, it's all about the net. Here we are 20 years later and still stuck with that name. This sent Microsoft into overdrive, talking about XML web services using SOAP. We could write our own, we're using ASMX files, or later we were using WCF. Or we could consume services from other people that had been written in other languages, like Java, for example. It didn't matter. It got applications to talk to one another over HTTP, which was way better than the horrors of DCOM or Corbo, if anyone remembers those. Much like working with stored procedures for database access, you need a lot of boilerplate code to work with web services because you've not got to connect to the web service, send it a command, interpret the results, deserialize it, all this sort of stuff. Luckily, we got a wizard with Visual Studio to generate that code for us. Later, when WCF came along, we got a command line tool as well. So with the wizard, you pointed at the WSDL definition for the SOAP service you wanted to connect to. And after a few choices, you got some code come out. Now, the problem with the code generated was that if you edited the file and then needed to run the wizard again, any changes you made in that file would be lost. So to get around that, the generated code had event hooks that you could wire up. So you had event handlers for any customization that you wanted to do. Now, lastly, as the tools were closed source, you had no control over the quality of the code. You were stuck with whatever Microsoft had deemed the right way for this code to work. Now, if you changed your style cop or FX cop sort of customized settings for doing your source code analysis, these might have sort of gone, oh, I don't really like this. You had no way of changing that code. Now, if you look at VS 2022, you now get more service options that we'll talk about later. But on that last point about code quality, in later versions of .NET, we started to see the use of this generated code attribute. This can now be used by compilers and analyzers like StyleCop, or if you're using ReSharper to analyze your code. These can go, this is auto-generated code. I may not apply coding standards and code coverage against these. So if we go back to our 3 rules of source code generation, we need to add some more boxes to our things to consider when generating code. The code we generate needs to be of high quality and decorated as being auto-generated, so that things like analyzers know not to actually go and sort of analyze them for things like code quality. The code it generates is effectively immutable. If we generate it again, any custom changes made by the developer will be lost. And because of that, we need to provide some way for developers to add customizations that won't get lost if the generator is run again. So we've already addressed the first of these code quality things by having the attribute. But the last 2 points have had an influence on the C# language itself to support source code generation. So in C#2, the partial keyword was introduced so that a class could be split into multiple files. This was mainly around things like Windows Forms. So you had the designer in Visual Studio that would do all the stuff generated when you drag controls onto the surface. You didn't want to be touching that file, but the other half of the class, you wanted to write your actual custom code. This split meant that the code generator didn't need to worry about identifying which bits of the file were generated and which bits were manually created. Now, that was a problem in the very first version of Visual Studio, where I certainly lost lots of code because I'd put stuff in the wrong place. So that was brilliant. That was around, I think, the 2005 era. But there was still a problem. Some developers would still make changes to the generated code and then get very cross when their code got wiped out by the change made by the IDE. So in C#3, we then got partial method declarations, not just partial classes. This allowed for authors of code generators to provide stub points in the generated code for you to provide your own code, rather than wiring up event handlers. Now, for those of you familiar with the Gang of 4 design patterns, this is effectively an implementation of the strategy pattern. Some restrictions were put in place, though, so that if you didn't provide an implementation, the call to the method can be ignored when compiling, which meant that the method needed to be private, and by default, you couldn't actually put any modifiers around it. And that still applies to this day if you use this method. You can't have any return values, because you can't, if it's code that can be no-opt by the compiler, you don't want anything to be able to sort of call it. And lastly, you can't have any out parameters for the very same reason. When we get to C#9 and now C#10 and coming up C#11, these restrictions have been removed. This is to support source code generators that we're going to talk about a bit later. But what it does mean is that if you don't stick to the C#3 restrictions, you must provide an implementation. Otherwise, Roslyn is going to raise a compiler error for you. So I've covered SOAP services, but these days we have 2 much more modern methods of doing inter sort of service communications. First, we have OpenAPI, sort of sometimes called Swagger, for HTTP JSON services, and gRPC, the new kid on the block, which is sort of kind of binary equivalent using proto definitions. So for REST clients, or HTTP clients rather, the wizard adds an OpenAPI reference to your project file, which adds a calls to the nswag libraries as part of the build chain. This isn't that well documented, so I've got a blog post link at the bottom with all the commands that you need to configure the output exactly as you want. For gRPC, as well as client proxies, we can create code that acts as a server or simply generate the message classes that we want and put them in their own class library. So in VS 2005, we got some tooling to help manage things like horrible XML config files and resource files. Prior to this, writing the code to navigate these files was clunky and error prone. So having a visual tool that could generate code was a big help. So here we can see the Visual Settings Designer, where you could create your own configuration settings. This would update the config file for you. It also created a static class that provided strongly typed methods to retrieve the settings. Now, the problem with this was that the config file could be manually edited and things started to go very wrong. Writing this type of generator was not limited to Microsoft, though. You could write one yourself. But you really wouldn't want to, as there's a whole ton of plumbing to do with COM interrupt that you have to do to make it work inside Visual Studio. It was horrible. I had a look once and I ran away screaming, like the kid in the slide. So that covers some of the tooling that's baked into Visual Studio. But what about defining code using templates? Now, whilst Visual Studio added some built-in code generation tooling, there was still room for template-driven generators. One that I used a lot in the early days of .NET was My Generation, where you got a dedicated IDE to write your templates with IntelliSense. I think another commercial one was, I think it was called CodeSmith. And that was a very good one as well. But these kinds of tools, they're mainly around database-centric stuff about making calls to database store procedures or writing CRUD statements, like we saw in that earlier one I had in the VB days. These fell out of fashion a bit with the popularity of ORMs such as NHibernate and later Entity Framework. Since VS 2015, we've had the ability to use text templates in Visual Studio to generate code at design time. This is done by associating a template generator with a particular file extension. This uses a version of custom tool code generators that I talked about earlier. Now, there's a few limitations to T4 templates. The first is that it's very much a Visual Studio thing with some limited support outside. I think Rider supports it, but if you're looking at things like VS Code, well, forget it, it's not going to happen. Because of that, the code you use inside of the template to drive the code generation is limited to .NET Framework, as .NET Core and .NET 6 aren't supported because Visual Studio doesn't use those. It's still based heavily around .NET Framework. That said, in Visual Studio 2022, at least you can now use them to generate code that targets .NET 6, even if you can't write the code inside the template using .NET 6. Whilst I said that I wasn't going to focus on runtime code generation, I think it's worth mentioning some of the techniques that you might have used over the last few years. Getting back to when .NET first came out, we were introduced to reflection. Now, we didn't have this in VB 3 to 6. This finally gave us a way to inspect methods and properties on a type and even call methods at runtime. As I mentioned at the start of the talk, this is heavily used by things like the JSON serializers. But what is less well known is that reflection can also generate code on the fly. It does this in memory by using the reflection emit, and it can execute it at runtime. Now, proceed with caution on this because this is a major security thing, and this is why things like Apple, if you're doing multi-platform targeting, you can't do this, because what's going on is behind the scenes, it's effectively writing low-level MSIL and compiling it on the fly in memory and then executing it, which would be a huge security concern. Now, as you can see from there, every command is an opcode in MSIL, a bit like going back to writing machine code like I did on the Spectrum. In other words, it was really complicated, huge pain to both write and debug, so not really used that much. I expect most of you are familiar with regex classes for matching strings against regular expressions. And there's the joke, I had a problem, I used regex, now I've got two problems. But under the hood, regex is actually creating a new class using that reflection emit, and that does the stuff that performs the matching expression. So it's actually generating the code from your regex expression on the fly. Now, the problem is by default, each time you use it, it's generating that code again, so performance is not great. To get around this, there are a couple of options to help with you either cache it when the application first starts up, or can compile the MSIL to an assembly file when you first generate it. Outside of Microsoft, other code generation developments going on in the world, such as aspect-oriented programming. These take another approach to code generation known as IL weaving. Now, it's a complicated process, and I'm far from being an expert in it. But the key factor here is that these tools take over the compilation process and intercept it at certain stages to look for parts of the code, where as a developer, you just don't want to be writing boilerplate code. So these might be things to do with logging, or if you're doing things like WPF, property change notifications, maybe even error exception handling. What is interesting about IL weaving is that unlike other code generators, is the ability to rewrite your code at the compilation stage. Now, it's something I said in our golden rules, that the code is immutable. IL weaving gets around those rules because basically it's hooking into the compilation process. If you're interested in IL weaving tooling, there's FODI, which is open source. However, the one that you're more likely to have heard of is PostSharp, which is a commercial product. The team at PostSharp have also now got a new version called MetaLlama, which is now based on a fork of the Roslyn compiler. I won't go into expression trees in that much detail, as that would be a talk to itself. They're really quite complex. But for the purpose of this talk, they're a way of describing code declaratively, which is the underpinning of things like link and entity framework, as they can be used to express a query that can be used by different providers to generate code to execute the query in some other language. So for example, in the entity framework, you've got the providers for T-SQL, in SQL Server, Postgres, and so on. They're a way of describing the code in a tree that can then be used to turn it into other languages. Now, ORMs like Entity Framework, as I say, use a combination of all the previous techniques I've discussed so far. You've got sort of the things that can scaffold entity classes from database schemas. You've got the code, you've got the expression trees that can go and execute database commands for you. And then you've got reflection that can then bind the results into .NET objects. So all the .NET generators I've covered off so far have all had one or more problems in terms of just getting code to generate some code for us within the projects. They've either been complex and hard to understand, or do things like write IL, which is way beyond my brain to understand. Some are just plain complex to use because you've got to have plugins, you've got to use installers, you've got to have command line tools. Some are external that run outside Visual Studio, or some only run inside Visual Studio. Some are limited to .NET Framework. Some only have a subset of .NET Core or .NET 6 support. Some are closed source, so you can't make any changes to how or what they generate. So that's been about how we've done code generation in the past. Let's come smack bang up to date. So we get to November 2020 and the release of .NET 5, where we're introduced to Roslyn source code generators. Now, Stefan's going to do a deep dive into these a bit later. So for now, I'm just going to give you an overview as to how these differ from the generators I've talked about so far. First and foremost, you write them in C# and they generate true 100% regular C#, or you can do VB. You're not dealing with MSIL or anything like that. You're generating real C#. Secondly, they're not tied to using wizards or plugins for Visual Studio. This is wholly about interacting directly with the Roslyn compiler. Unlike IL weavers, they can't rewrite code that you have written. All it can do is create new code that either stands on its own, so you might create a new class or struct or type of some description, or extends one of your own classes using the partial methods that I talked about earlier. Now, this picture from Microsoft Docs summarizes the source code generator chain quite nicely. As you can see, the source code generator gets called as part of the compilation build chain. When it is called, you can analyze code and additional files in the consuming project. And this generates new code, which gets acted back into the compilation process. Now, these new generators can be as simple as complex as your requirements demand. Ultimately, the goal of the generator is to generate code as an in-memory string that is used as part of the Roslyn compiler, as if you'd written it as part of your own C# code. There's no need for templates unless you want to go down that route. I think Stefan's done some stuff with templates before, but whereas previously you had to have a template and you had to sort of have various tokens in there, now you're building up a string in memory as part of your generator. What I really like about these is that you don't have to write installers for these. So the things like the T4 templates, you had to sort of mess about with writing installers for. You can have a generator project as part of your solution, side by side with your own code, if that generator is just local to what you want to do inside your solution. If you want to share your generator with your team or with the community, much wider community in general, you can create a NuGet package out of it. There's a handful of libraries needed to write a code generator that I've shown here, but Stefan's going to talk about these a bit more later. The key thing to note is the generator needs to be a .NET Standard 2 library, as it needs to be able to run both with the Roslyn compiler, but also with Visual Studio. And as I said earlier, Visual Studio is mainly focused, but the actual execution within Visual Studio is based around the .NET framework. Since VS 16.10, there's now debugger support been added. But to make the most of this, you need to use the isRoslyn component property and set it to true. And I think Stefan's going to talk a bit about that a bit more later. The first thing you need to do when writing a new source code generator is decorate the class with the generator attribute. When first introduced in .NET 5, you needed to implement the iSource generator interface, which has two methods, initialize and execute. Now, I'm not going to spend too much time describing these, as there's a new interface in .NET 6 that supersedes the source generator interface. However, to provide some background, the two methods were called at different points in the compiler chain. First, the initialize method is where you register your generator with the Roslyn compiler, so it gets invoked whenever a compilation takes place. The execute method is where you do the work of inspecting the metadata you are interested in and generate code as a string. That then gets added into the compilation at the end of your execute method so that Roslyn can then inject it into the whole compilation. Now, one of the problems with the .NET 5 version of source code generators is that they could really slow Visual Studio down. Because what was happening was, as you do each key press, at certain points, Visual Studio would kick in and do a new code generation so that things like IntelliSense would work. When Microsoft started to use them against the CLR, they realized this was a massive problem because they've got massive solutions with massive projects, and it really slowed everything down. So in .NET 6, there's a new version of source code generators that's much better. In .NET 6 and version 4 of Roslyn, there's the new Incremental generator interface. This was added so that it allows you to effectively build a pipeline, if you think of it a bit like middleware in ASP.NET. So the code goes through various stages of a pipeline. This allows you to filter out any code that you're not really interested in. It also allows the Roslyn to cache stuff as well, so that if something hasn't changed, it doesn't have to go and recompile stuff all over again because it's already compiled part of it. That way, you only need a code generation if your syntax criteria has either been met by some new code or some code that has changed. And Stefan's going to go into much more detail in his talk in a little bit. This is where I come full circle to what I learned over 30 years ago, writing that code generator for the Spectrum. It's all about understanding the language syntax for the code you're generating, just as I had to for that program on the Spectrum. However, in the case of source generators, the input is also code that someone else has written. It's not just reading memory or just reading a JSON file or something like that. You have to understand how to parse other people's C# or VB code. So to work with it, you need to understand how to navigate that code and how to understand what it is you're looking for and how to react to it. Now, there's two ways of doing this: syntax trees and semantic trees. So let's start with syntax trees. If you've ever looked at writing Roslyn analyzers, you may already be familiar with these, but I'll go through it for those that are not. When you write your C# code, every character in your code contributes to either become one part of one of these three categories of code. A bit like I had to consider different keyboard modes on the Spectrum. Starting with the simplest on the left, trivia is mainly stuff that we're not interested in. That's things like white space formatting, comments, preprocessor directives. Tokens are the lowest level of syntax that can't be broken down any further. So these are your C# keywords, the names of your variables, text literals, punctuation, such as the end of statement semicolons, things like that. Not a million miles away from when I was looking up keyboard syntax tables on the Spectrum ROM, as I showed earlier. Everything is all about tokens. These then get bundled up into syntax nodes, which are groups of tokens that form declarations, statements, clauses, and expressions. So when you've got a line of code, that is effectively one of these syntax nodes. These nodes are effectively your program split out into a tree that can then be queried by code. Now, there's a great website called SharpLab.io where you can paste your code in and do various things that look, and you can do things like see how C# rewrites itself into lower level code. You can see the IL that gets generated. But the feature we're interested in here is viewing the syntax trees, which I've got on the right. This shows how your code breaks down into these smaller nodes of the syntax tree. Now, Stefan's going to do a drill down later in his demo of using SharpLab to see how a bit of code can be expressed using the syntax tree. So I'm not going to go into much more detail in this talk. Now, so far, we've concentrated on syntax analysis, but that's not the whole story. While a syntax tree tells you what the code looks like, so you can spot things like a class being or a method being decorated with an attribute, the text that actually went into making up that code, semantic trees give some actual sort of structure to that code. So if you're used to using reflection, you can look at a class or a type and say, what are the methods? What are the properties? What the access levels, things like that. The semantic tree is a bit like using reflection, but it's at compile time rather than runtime. But this is what makes source code generators a good replacement for anywhere that you're using reflection at the moment, because you could write a source code generator to do the things that you would do with reflection at runtime. Now, sometimes you might be doing something like, for example, converting enums to strings. When that's done at runtime, there's some reflection going on, and he then sort of does some IL on the fly to actually work that out. If you've got a source code generator that can understand your enums, then it can actually generate a class that says, if your first enum value, then this is the string value, and keep going down like that and generate that as code that gets executed at runtime. As I say, Stefan's going to go into more detail on this in his talk a bit later. But you're not just limited to looking at C# code with source code generators. You can inspect other files as well. Inside your C# project, you can mark files as additional files in your consuming project. So for example, you may have some data in JSON or a CSV file that you want to convert into an enum type. If you're really ambitious, you could even write your own domain-specific language. And then you could write a parser that sits inside your code generator that can inspect these files and convert it to C# code. So to summarize why source code generators are great compared with what's gone before. For me, being part of the compiler chain is not being tied to Visual Studio or some external tooling. That opens up all sorts of possibilities. Being part of that chain means that the compiler generates the code for you as it reacts to code changes in your code. It's more of an IDE feature. This is more of an IDE feature about calling the compiler as code is entered. But it does mean that your code base for both your code as you enter and the code that is generated is constantly being checked as you type it. Having additional files means that if you want, you can create your own domain-specific language that you can compile into C# code. What I like most, though, is that a lot of the things I used to do in reflection can now be done at compile time, and you get much better performance. Lastly, with the improvements made to VS 2022 to support code generators, you can now easily get to the generated code and the IntelliSense that's referencing it in your code. But like all the generators I talked about earlier, there are some limitations. The first, as I've said earlier, is that the code needs to target .NET Standard 2. You can't just target .NET 6 and you can't target .NET Framework. This is because of the way that it needs to interact with both the Roslyn compiler and Visual Studio, which is still based around .NET Framework. The next thing to consider is that the generator may get called hundreds of times while editing code in Visual Studio. So if you don't want to you really don't want to rely on things that do I/O and have latency. So you definitely don't want to be calling databases or making HTTP API calls, because A, that's going to slow things down. B, what happens if you lose your connection? C, it could be a complete memory hog. So you definitely don't want to be doing that. if you really do need something like the results of an HTTP API call, then make that call at design time, pull down the results into a JSON file, and then interrogate that. The last problem is that you're limited to generating just C# or VB code. You can't create text files like JSON files based on some C#, though there is a proposal to do that. F# isn't supported because Roslyn isn't part of the F# compiler chain. But what happens when your generator doesn't work or there are problems with the code that is generated? One big problem is when debugging is that Visual Studio aggressively caches the generator the first time it's built. So you could have your generator, you've coded it, you're making use of it, you make a change, and you don't see any changes whatsoever in your code. So you have to restart Visual Studio, and then your changes will kick in all over again. They talk about the developer sort of loop, and the last thing you want to do is keep restarting Visual Studio over and over again. One way around that is, I've done this before, is I've created my own build profile. And then what I've done is I've put an if debugger, if the debugger's enabled, then, or rather if the debugger's not enabled, go and launch the debugger. And then you can call it from the .NET command line. A better way to debug your generator is to write unit tests. This gets a bit messy, as you have to write loads of code to be consumed by the compiler and then force the compilation via the compiler API. However, what it does do is gives you the ability to test different scenarios, set breakpoints, and step through your code without Visual Studio's caching getting in your way. And I think Stefan's going to do a demo of that in his talk a little bit later. I'm looking up. Are you nodding, Stefan? I've got a couple of links here, but I've put them all in the GitHub gist at the top of the slides. The first is a set of links to the whole load of source code generator projects that you can use or look at if you want to see how someone, whether someone's already written a source code generator you're thinking of writing yourself. The second is some general guidance about writing source code generators. So I think it's a little bit out of date. I'm not so sure it's been that updated for incremental source code generators. But since .NET 6, Microsoft has started to use source code generators to improve some of its own code. There's not a lot to say about the Razor compiler feature, as it's turned on by default. But what happens is it means that your Razor views get a bit of a performance boost in Blazor and MVC. For login, you can now write a partial method with an attribute, and the generator will generate a load of the boilerplate code for you. So all the stuff where you do the is enabled, you don't need to do yourself. In fact, there's an example there. So all you've got to do is say, create a partial void method with a logger message, the event ID, and your message, and it does a lot of the magic for you that you can see in the code below. Now, the big source code generator enhancement in .NET 6 is the updates made to the JSON serializers. Now, still in .NET 5, the system.text.json serializer was still using reflection, much like Newtonsoft's did. But with .NET 6, Microsoft grasped the nettle and added functionality that takes advantage of the source code generators to not only handle the serialization, but also do stuff with the data model via the JSON serialization context. There's a whole lot of new stuff in here, but the main highlights are if you do not change your .NET 5 code, it will still use reflection-based serialization. But you do get two new source code generation options. One is it generates code that optimizes the serialization process, and the other optimizes deserialization. Now, in most cases, you can use both of these together, but there are some situations such as async serialization where you can't use the generated serialization because of some threading issues. But what's coming up in .NET 7, which is out, not long now, couple of weeks. As I said at the start of my talk, regex has previously used reflection to generate matching code at runtime. In .NET 7, if you have a constant regex pattern, you can now generate the code that does the matching at compile time. All you need is to create a static partial method and decorate it with the new generated regex attribute and the regex pattern that you want to use for matching. Now, as I mentioned earlier, you can open this analyzers in the Solution Explorer and see the code generated. What is nice about this generator is that at the top, it gives you an explanation of what the regular expression pattern is going to do. So you can see I had an expression that passed a URL to make sure it's got HTTP and all that. And it explains that at the top in the comments. Now, I ran some benchmarks over the weekend and compared with newing up a regex each time that you want to do that is match, the performance boost is incredible. Even if you cache the regex instance, the isMatch method is still much, much faster. So that's a major boost to it. Another source generator attribute is the library import, which can be used to replace DLL import for calling native code. This is useful if you have code that interacts with native libraries on specific platforms. Now, I think that is quite niche, especially if you're doing multi-platform stuff. But it's interesting to see that Microsoft is making inroads into sort of spreading the source code goodness all over the place. So the generated code for this one does some basic marshalling between managed and unmanaged code that previously would have been done generating some IL at runtime. So you'd have had a bit of a performance hit doing that code. In C# 11, we have a new access modifier that's been introduced specifically with source code generators in mind. Now, you may have a type that you generate whose name may clash with the type that the consumer has declared in their project. Previously, you would have worked around this by having a custom namespace, but even then, you can't guarantee that your custom namespace won't clash with a namespace that someone who's consuming your code generator is using as well. So in C# 11, if the type you generate is only used by the code inside your generator, the code that you're generating, you can now limit the scope of your code generated string, which is treated like a virtual file. One of the pain points for source code generators is that you are building up a string of C# and VB code. And you're going to have quotes and curly braces and $signs in there. Now, currently in C# 10 and .NET 6, you have to escape all that. And it's really painful when you're trying to debug your source code generator. So in C# 11, we now get raw string literals. This allows you to use multiple quote marks to denote that the code inside it doesn't need escaping. And that's, I think, a major boon for writing your own source code generators. So hopefully we've established that source code generators are great. I love them. Stefan loves them. They're brilliant. But as they say in Spider-Man, with great power comes great responsibility. The one thing I do need to point out is that with all this power, you have to be careful. If you're using a generator that's been put on NuGet, how do you trust it not to be a bad actor and do something nefarious while looking at your code? It's really up to you as a consumer to do the due diligence to see if you can trust the generator you plan to use. Now, given that a source code generator has access to your source code, do you trust it not to be logging its code analysis results somewhere? Who knows? We've seen things where we've had build tools been hacked and sort of logging information away. So you do need to be careful. That leads to the second point. Do you have the source code for the generator so that you can check that? Lastly, if you're reviewing code that is being generated as part of pull, let me try that again. Lastly, are you reviewing the code that's being generated as part of your pull requests before it gets merged into the main CI pipeline? Now, since version 16.10 of Visual Studio, you can actually see the code generated by navigating to it through the Analyzer node in Solution Explorer. Now, it's worth saying that you should check the generated code both in debug and release modes in case there's a difference in the code being generated, because it might be that if you have got a nefarious attack going on, they might go, okay, I'll generate good code in debug mode, but bad code in release mode. And you might not be actually testing it in release mode on your machine, but you should. It's also worth mentioning you can add some flags in your CS proj file so that the generated code actually does get saved to disk. By default, it's just generated it's virtual, it's in memory. But you could actually get the code generated to land on the disk as part of your project and check it as part of your source control so it can be code reviewed. So there are three simple rules when it comes to reviewing source code generators. First, if it's open source, can you check the source code and has the NuGet package come from a known repository? If it's a commercial package, do you trust the vendor and has it been digitally signed so it hasn't been tampered with? Lastly, if your team's writing its own generator, is it going through code reviews and pull requests before being actually used? So we covered 33 years of source code generation. But where is source code generation going to go next? Now, my kids at school use things like Scratch and the BBC Microbit for learning how to program. Now, I think this is a brilliant way to learn to programming by doing drag and drop. It takes me back to the old VB3 days. But what I like about this, especially the Microbit emulator that's on the Microsoft site, is that when you've done all your dragging around, you can go up to the top and say, I want to see the code that this generates. So I think it should, if I'm waiting for the video to catch up with me. So then you can see that code in Python. Now, there's been a lot of buzz lately about GitHub's Copilot and Microsoft's IntelliCode that's in Visual Studio. So these tools use knowledge gained from analyzing public GitHub repos to understand common coding practices, and they try and anticipate the code that you're going to type. I know that Jimmy Engstrom, he's been writing a Spectrum emulator in Blazor, and he had bizarre things where GitHub Copilot automatically knew how to do certain things that were very specific about the Spectrum, not C#. It knew about Spectrum stuff as well. Really quite freaky. Taking this step further, the engine that sits underneath GitHub Copilot is the OpenAI Codex. Now, they've got a demo on their website which shows you how it can translate from natural language into JavaScript. So I'll leave this running for a couple of seconds while I just have a sip of water. So as you can see, there's just this natural language of add an image, resize it, make it bounce around, and it can generate the JavaScript for you. Now, taking this to the extreme, a team at NVIDIA used its GameGAN AI engine to recreate a fully working version of Pac-Man for its 40th birthday. Now, what is very cool and very scary is that by studying 50,000 games being played of Pac-Man, the AI engine was able to generate the code itself to recreate Pac-Man as a game. No game engine involved. This was all generated by AI. Now, that is source code generation in the extreme and very, very scary. So we're coming to the end of my part of the talk. In summary, source code generators come down to two things. Metadata provides the input for your source code generation. This could be from any number of sources, as we've seen, be it API structures, databases, JSON, especially in C# source generators, other people's code. Anything that you can analyze and get meaning from can be a source code generator. The second is the syntax. You need to understand how to construct code that will compile correctly. To do this, you need to do lots of testing to ensure that whatever someone throws at your generator will still generate code that can compile. That about wraps it up from me. We've got Stefan coming up shortly with his much more deeper dive. That was just more of an introduction to source code generators and an old man talking a lot of old rubbish about old source code generators from 30 years ago. Thank you for listening to me. As I said, there's some links from the slides on where you can hear me waffle on about stuff about dependency injection and configuration. That's on the GitHub gist that I've got on the link at the top. And that is just about me. Are there any, there's nothing on Slido, is there anything in chat?
There is on the Slido only one question, which is from me. If you will share the slides, and
they're quite interactive. But what I can do is I can generate a PDF version that I can share.
That would be great.
Okay.
All right. So thank you so much, Steve. That was fantastic.
Thank you.
Also,
I'll stop
learned
sharing
quite a
my
bit
screen
about the new features coming. I think it's quite quite exciting. And to the audience, don't fear asking any questions. You can put them in Slido or ask them in the chat or ask they as they come. So, yep. And yeah, you can have this reaction to clap as well.
Thank you.
That's pretty cool.
I was very conscious that I was rattling it through at quite at speed, but I had a lot of content to get through before handing over to Stefan.
Already. So if there are no questions, Stefan, stage is yours.
Ooh. Thank you very much, Steve. It was amazing. Every time, I think it's the third time I listen to this talk, and I love how you continuously evolve it and upgrade it with the latest features. So I enjoy it every time a little bit more.
.NET keeps moving, so you have to keep up with the times.
Yeah, indeed. It's like what I'm talking today is obsolete in 2 weeks, isn't it?
Yep, that is the problem.
It's an exciting problem.
Yeah.
Welcome to my part of this double session. Never send a human to the machine's job, to quote a villain of one of my most favorite movies. My name is Stefan Pölz. I seem to have a very weird Twitter handle. Naming is hard. I've been doing .NET for roughly 10 years now. I started with Roslyn in 2020. Right when the pandemic hit, started with analyzers that Steve also mentioned, and investigating source generators since they came out with .NET 5 2 years ago. And currently I am working at Trayport in the office in Vienna, which is the primary network and platform for European wholesale energy markets. And there is actually a high chance that the equipment I'm running to give this presentation and to talk with you tonight is powered by energy which has been traded through our platform. However, this talk is entirely my own. I am also a co-organizer of the .NET Devs meetup group here in Austria, here in Vienna, and a JetBrains community contributor. All my socials I list at the end. Again, if you later on, when you start experimenting with generators yourself, if you have a question or some problem, or perhaps would like to start a discussion. But now let's jump into it. Don't be afraid. A lot of stuff Steve covered already, so we will deduplicate the overlap. Here I'm listing those Roslyn components that you as a consumer of Roslyn can actually extend. So you can write, for example, analyzers or code fixes, which are offering a Control-Dot or Alt-Enter experience to fix warnings, for example. And we will have a look at those two interfaces. Steve already mentioned them. So this is the first duplication. The source generators that are in the BCL in both .NET 6 and the upcoming .NET 7. Also the language features. I'll be not using the newer C# 11 file script types just yet, but they are about to be very helpful. And to briefly reiterate on the laws of source generation, Steve mentioned the syntax trees and the semantic models and how source generators can only add new code. They cannot change or remove existing code. And this is very important to keep in mind. And since source generators technically are analyzers, if we later on have a look at CS projects, you will see the word analyzer a lot. They can also emit, they can also report diagnostics such as warnings or errors, or maybe infos. So you get sweet little dots in Visual Studio. And one important thing is that source generators are unordered. That means that one source generator cannot depend on a different source generator. They do run in a deterministic order, but this is not documented and may change. And the output of one generator is not the input to the next generator. There is no order. Every source generator sees the same user code. There is a feature with which you can circumvent this to some degree. But I'll come to that in a couple of minutes. Yeah, Steve mentioned the anatomy of the generators, the packages you need, the net standard 2 that we need to target, and how the source generator is looking like. So this is the source generator that was introduced with .NET 5, or in Roslyn versions, it's version 3.8. And let's have a look at an example. So I'll be jumping into Rider, since it's a Roslyn feature. Steve mentioned it works in both Visual Studio and also Rider, or you could also build them with VS Code or just Notepad if you wish. All you need is the SDK. However, the editors do have nice features that would be painful to work without. So I have a little bit of an example here. And I have here a partial class that has a partial method. And this partial method here is already using the C#9 partial method syntax, because this one it's not void, it actually returns a type, and also it has explicit accessibility. So as Steve mentioned, this is no longer the C#3 partial method, this is the C#9 partial method. So there must be an implementation of this partial method provided. Otherwise, compilation would fail. But where is it? If I hit F12, I'm jumping to this file. And Rider now highlights this file in yellow, which indicates this is a generated file. This is not coming from the user. Visual Studio, it's very, very similar. And now we have a look at how this code is generated. So we basically have a look at what this syntax tree looks like. So I'll be jumping to Sharplab, sharplab.io, and paste in the code. Let's only show the interesting part. And we have a look at the syntax tree, where we see that we have the entire thing is the compilation unit. Then we have a class declaration. A class declaration has several modifiers. There is the public keyword, the static keyword, the partial keyword. Then there is the class keyword. This could be also a struct keyword, for example, or a record keyword. And we have an identifier, which as a value has helper as its name. And now this class declaration or a struct declaration or any type declaration has members. One of these members now is the method declaration. And when we highlight here, we actually see what the C# representation is. And again, this method declaration, it has the internal keyword, static keyword, so it has a couple of modifiers, and it has a return type, and again, an identifier. And now the source generator receives this syntax tree representation and receives all of the user codes in this CS project, in this compilation, receives all the user input as syntax tree, or all the user code as input in form of a syntax tree. So the source generator has to pick what code it's actually interested in. So we have here a couple of features. First of all, if we want to extend a method, the class this method is contained in has to be partial. So we'll be looking for partial classes. Also, we will be looking for methods which are partial and return a string. We could also indicate that, for example, this method has no parameters or has no generic type parameters and so on. So there's various aspects we could have a look at. We could, for example, scan for a specific attribute which is put onto this type or this method. And when we now jump into the generator, so I'll briefly have a look at the CS Purge. This is a Roslyn 3.8 I source generator, so the one that was shipped with .NET 5. And we see exactly the features that Steve has mentioned. So we have the generator attribute. The tooling knows, okay, this is a generator. I need to load this. There is the initialize and the execute method I should run. We implement the iSource generator interface, which expects two methods, the initialize and the execute. In the initialize, this is optional, but what I like to do is this makes scanning quite easy. We can register a syntax receiver. And if we jump into syntax receiver, it's a type which implements the iSyntax receiver interface. We have the onVisit syntax node method, which now gets each and every node. So everything that we saw in SharpLab, it gets the class declaration, it gets the method declaration, and so on. Each and every node in each and every syntax node in this compilation is passed into this method. And now we filter. So we said that we were searching for methods. And so we check if the syntax node is the method declaration syntax. Also, we said we should check if it's partial. So we have a look if the modifiers contain the partial keyword. Otherwise, we can't really extend it. It would be a compiler error. And we scan if the return type is a predefined type syntax. So we're actually scanning for the string keyword. Now, this generator wouldn't work if we would use system.string, for example, if we would use the BCL type, because we are specifically scanning for the predefined type syntax, which is using the string keyword. And then we add these to the candidates. So this is a purely syntactic check. We haven't checked any meaning of this code, actually. And now with these candidates, we go into the execution phase of the generator, where we get a hold of the syntax receiver, iterate through the candidates, and now the semantic model comes in place. With the semantic model, we get the actual type information, so the actual meaning of code. This, for example, comes in play if we, for example, would be referring to system.string. But who knows now if this is the system.string which comes from the BCL, or this is perhaps a user-defined system string in a different namespace, or actually in the very same namespace. So it has the same name. So from a syntactic point of view, it looks the same, but semantically, it's a totally different type. So syntactically, we may not be able to differentiate, but semantically, we can. This is what we can use the semantic model to ask questions about type information. So we get a hold of the declared symbol. So we will basically convert this syntax node, this method declaration, into a method symbol, which now has type information for us, where we also get a hold of the containing type, because we need the containing type to generate the new code, because the method that we want to partially extend, we also need to put into a partially extended type. So then there's different ways of creating the string, because as Steve mentioned, the output is a string, pure C# code. I'm using a string writer here, wrapping this in an indented text writer so we can have indentation. And we create the partial class with the type name. We create then, as a member, the partial method, which returns string with the name. So the get name that we use is arbitrary. It could be anything. We also apply the accessibility that the user has written. And then we just return the string from generator. We see we have here, so the double quotes, war string literals will make code like this way more readable. And then we invoke the add source method, where we can pass this hint name. This hint name is used for tooling, But as Steve mentioned, we can enable a compiler flag, and then it's actually also put to disk and then has the hint name.g.cs name. It's always a good practice to add the .g.cs or .generated.cs so that tooling knows, okay, this is a generated file. Analyzing this code may not be the best idea because the user has no direct influence upon what the generator creates. And then we return the string. And this is how we get now, if we have a look into this example project, we can go to the dependencies tab, have a look at the source generators tab, and see here this file. In Visual Studio, this is very similar in the dependencies tab. So we see this generator is creating the hint name.g.cs file, and there is the code. So if I would put this down here and have the program, so that basically the source up here, and I would change the method name now to something else. Let's say hello. The generator kicks in, and also now the generated part has also been renamed, because in our generator, we are not hard coding the get, we're actually getting the name from the symbol information that the user has defined. So I also have to rename it here. And now we can run the program again. So we get in the console the from generator that was generated. I list here a couple of tools. So the SharpLab, as Steve mentioned, I'm using here as well. Visual Studio has a syntax visualizer integrated. Perhaps I briefly show this. This is a special, not a workload, but it's a component that you have to install first. And if we now jump to this program here, we can enable the syntax visualizer tab, which now basically shows the very same that we saw in SharpLab. So we have our compilation unit, we have our class declaration, which has the keywords. We get some color highlighting. So this is a token. We have here some trivia, and here are the nodes in blue. Now, also, I want to show the debugging experience live. So let me go to this chart. This is now only working in Visual Studio. I'll hit a breakpoint into the execute of the same generator that we had a look at in Rider. I'll select this generator as a startup project, and because I set those properties that we had a look at in Steve's session, we can basically run it, and we hit the breakpoint. So we will get folder experience. We have all the locals. We get our call stacks. We can step through our code. We can have a look at the quick watch and have a look what this method symbol is composed of. So we see this is, for example, a partial definition, and so on and so forth. This does not work in Rider. However, you could have the unit test and debug into a unit test, and then have a not the same but very comparable debugging experience. I also want to mention nullable reference types. I really love nullable reference type, and the Roslyn APIs, those Microsoft.codeanalysis.packages, are all, the later versions are all annotated with nullable reference types. But since the generator has to be Net Standard 2.0, we can't really capitalize it because the Net Standard 2.0 BCL is not annotated, so we can't really use it. So what I like to do is to multi-target the generator with the latest .NET version. However, it's important then if we create a NuGet package out of that, we need to specifically say, okay, the NuGet package must contain the Net Standard 2.0 version. So we can now suppress nullable warnings for net standard 2.0, but we would still get the nullable warnings for the net 6 build that we actually not be using. We only will be using it to get nullable warnings. But if we have warnings as errors or nullable warnings as errors, we would get nullability right. Now to some versioning. So I just showed the 3.8 version of Roslyn generators. So for these, we require the .NET 5 SDK. The next interesting version, or the next significant version for generators, was Roslyn 3.9. So if we write a Roslyn 3.9 generator, the consumer needs to have at least a .NET 5.0.200 SDK. So the first release of the SDK wouldn't work anymore. And this adds post-initialization. And this is how we could actually create code that another generator may depend on. So the example, no, actually, let me switch back to writer. So I have here a method. This method is totally generated. If I run it, it prints post-initialization. And if we have a look at what gets generated, we see this is this method, which returns post-initialization, and alongside with it, another file, which prints here post-initialization found was true. Let's have a look at the generator, what this means. So what we're doing here is now, it's still an iSource generator. With Roslyn 3.9, we can also indicate the language that this generator is generating for. So starting with 3.9, we could also generate Visual Basic code if we like. And we can, next to our syntax receiver, we can also register post-initialization. Now, post-initialization is quite uncontextual. If we have a look at this type, we see we have a cancellation token and the add source method. We have no compilation, we have no syntax node, we don't know anything in this phase of the compilation, we don't know anything about the user input. So this we could use to unconditionally generate some code. For example, this type with a method or maybe an attribute that we can then use later on. But everything generated in post-initialization is accessible to this and other generators as well. So if we now go to the execution phase, again, we filter for the syntax receiver and so on. But what we do now is we ask the compilation to give us this type that we created in the post-initialization phase of this generator. And we can verify that this is not null. So this type is actually accessible to this generator because it's initialized in the post-initialization. If it was emitted in the execution phase of this or another generator, it would not be visible and it would be null and this Boolean would be false. Now, what I'm also doing in this generator is I create the date time, the now, to show what Steve mentioned, that generators will execute a lot. So if I have a look at, oops, I closed it, at this generated file. Yes, I'll put it over here. And now in the program, I start typing. I just hit enter. And if we have a look at the date time, this will jump to, yeah, now it has been updated. And we currently have 325 nodes visited. So in the syntax receiver, I basically, if you have a look at the generator, in the syntax receiver, I just increment a counter. So for each and every node, we know how many nodes have been visited. And if I duplicate some lines, now previously we had 325 nodes visited, now it's 400. And although we haven't written any code that the generator is really interested in, so this actual post-initialization thing that we want to use is still the very same, we still have to run the entire generation again and again. And this is the thing. So if we have a huge solution with millions of nodes, this could be slow, because with every key press, we generate everything again. And this is where the programming model of incremental generators kicks in. And I want to show that through in the combination with additional files that Steve also mentioned, because we not only have access to the C# code of the user, but also additional files. So if we have a look at the CS project here, we see that I marked some XML files as additional files. And when we do this, now this makes this additional files accessible to the source generator. And now we are going into Roslyn 4.0 land. So this is now the code analysis 4.0.1. This is the version that was shipped with .NET 6. So we can use the incremental generators. And having a look at this generator, this is now implementing the incremental generator interface, which only has an initialize method. There is no explicit execution phase anymore. And what we do in the programming model of the incremental generator is building up a pipeline where each step of this pipeline is subject to caching, called memorization. So if subsequent runs of the generator create one step of this run, creates the same output than the previous run, all the subsequent steps can be skipped and their cached results reused. So we can short circuit parts of the pipeline that we built up, which would produce the very same result as with the previous key press. And what we do here is we don't have direct access to, for example, the additional files. All we have access to is so-called value providers. So we see incremental value provider and incremental values provider, where the value provider holds a single item, for example, the parse options. The parse options contain information, for example, about the language version that was used to compile that project, or if overflow checking is enabled or disabled per default. And we have the values provider, which contains 0 or many elements, for example, the additional texts. And now we build our pipeline very similar to LINQ. It's not LINQ. If we jump into this where here, we see this is not LINQ. This is a separate set of extensions, and it doesn't have all the power of LINQ, but it has the basics such as select many, aware selection, combine two different value providers, and also a collect to convert a values provider, a plural, into a singular value provider, where the result is now an immutable array, so a collection of items. And the first step of this pipeline will be we filter all the additional files which end with XML, because we are only interested in XML files. This also shows just as with the other generator, filter early as much out as possible, because this will reduce the pressure on subsequent steps if we narrow down the candidates as soon as possible. But also performance should be considered. So the best part is the best approach is to filter early significantly, but also as fast as possible. And then in the next step, now we know we only have additional text files which end in XML. We can select all of these files, invoke this get document method, which now gets the text of this additional file and parses it into an X document. And so we have here the select. This in return returns another incremental values provider, and that we chain now with the third step, where we filter all the documents which are not null, because we could return null here. So we have actually 3 steps in our pipeline. We have the value provider, we filter that actually we have 4 steps. So we take the value provider, we filter all the XML files, we convert these to XML documents, and then filter all the nulls there. And then we register a source output. So this now will be somewhat the execution of the generator, but we don't invoke it directly. We just register a callback with this more or less link result that we have built up. And in this method now, it's again the very same, or super similar. We have the source production context via which we can add the source code, and we get the result of the pipeline. And for each and every X document that we have, we invoke this method where we again build up a string builder, and we have a look at this XML document, and we generate a class out of that. So this is just some XML code. Perhaps I show the result at the end, and then we again add the source code. So let's have a look at this XML files that we have. It's basically converting XML to C# code. So I have here an XML document. I will be using this as a class name, and these will be the property names. The type will be the type of the properties, and the value here towards those properties will be initialized. And when the source generator runs, we can have a look again what it creates. Since we have 3 additional text files, it creates 1 generated file per file. And we have, for example, a look at this file. And here we see, okay, it creates the generated class taken from this XML document, uses the number as a property name, the type as the type, and here this value initialized here. Also, I'm using the generated code attribute that Steve mentioned is always a good habit. So actually here we see there is 3 good habits to mark your generated files. The hint name should end with .g.cs or .g.vb, depending on the language you're generating for, or having it full spelled .generated.cs or .generated.vb to indicate to tooling this is a generated file. Also, as a header, add a comment auto-generated. You could also add additional information such as your name, licensing, whatever, and add this attribute. Because, for example, using a comment, if you have a tool that uses, for example, reflection, the comment is gone. With reflection, you cannot access the auto-generated comment. So with reflection, you cannot determine if this type has been generated by some tool. But with attribute, that remains in the assembly as metadata. So via that tooling, reflection-based tooling can also figure out, okay, this is generated code. And I'm printing here now the time. So this is actually where I want to go to, because if I now go ahead and change, I have a look at the generated 1 file, but let me open the XML of generated file number 3. And if I be changing this file, so I'm changing the 3 into a 4 or into a 5 and save it. Actually, I don't have to save it, but I just saved it. We will see that the time here will not change. Oh, it actually changed. Perhaps this was the first execution. I'll type it again. And if we have a look, it won't change anymore. I guess this was the first one after I built. So let me change it again, and it will stay at this time. Because the pipeline does not generate everything all over again because we did some filtering. However, if we change now the text file 1 that we have here, and would be changing this 1 into a 9, for example, we will soon see that this 1 changes into a 9. And of course, the time will update. And there it is. So now the generator is only generating these files again that actually change and not unconditionally everything, which in a huge solution is a significant benefit. And the next significant version of Roslyn is 4.2 because there was a little bug fixed if you need the metadata, but this was basically a smaller bug. I guess the most sensible version to target is Roslyn 4.0 because the .NET 6 SDK is an LTS version. .NET 5 SDK is out of support already. So I guess it's safe to assume that consumers at least have the .NET 6 SDK. And I mentioned, so I mentioned performance. We saw that the onVisit syntax node of the syntax receiver is called for each and every syntax node, and how the programming model, the pipeline programming model of Incremental generator, can short circuit several steps of the pipeline that you build up. So it's very important that you are sensible about the setup of the pipeline to get great performance, even in large solutions such as the .NET BCL, the .NET Runtime repository. And most methods that we implement through interfaces also pass in the cancellation token. And if you have a loop with several iterations, it's a good thing to throw if cancellation was requested, and also pass it to Roslyn-based method, to Roslyn-based methods. If they take a cancellation token, then pass it through, because if the user presses a key while the generator is generating, then this is basically invalidated and could and should be aborted. So the new run can start because the old result would be irrelevant. And yes, so here I list a couple of properties that you need to use if you want to publish it as a NuGet package, as Steve mentioned, to share it. So since it's a generator, we don't really share the C# code itself as a library. So the types should only be accessible to the SDK, not to the user. So this is why we do not include the build output. And we indicate that this is a development dependency, which now for the consumer, if they install the package, will get private assets set to all, so that consumers do not get the dependency on Roslyn transitively. And also, if we do multi-targeting, we need to indicate that we want to consume the Net Standard 2.0 version of this generator, not the Net 6 version that we use for multi-targeting, because otherwise, wouldn't work with Visual Studio. And now we have a little bit of time left before I jump into the best practices to have a look at a more elaborate example of a source generator. So I'll be jumping into a new solution and briefly showcasing a little problem, a potential performance problem of structs. So I have a couple of tests here, and one test is failing. Why is this test failing? Because I have a struct, I have a read-only struct, which has two properties. And so we have a number and a text. And if we set here there is the failing test, yes. So if we create two instances of the struct and set the number in both versions to 1, but the string in both versions to a different string, we would expect that the hash code is different. However, we expect that it's not the same, but this test fails. It actually is the same hash code. And this is due to the default implementation of a value type. So every struct is implicitly inheriting from value type. We can't do this in C# code because a struct cannot inherit from a class. But this is if we have a look at reflection, actually have a test up here. So if we get the base type of a struct, it will be the value type. And we would inspect this one. I'll be using not sure if you know this site, but there is sites of .NET, which has like all the .NET entry points that you need. There is Roslyn, source roslyn.io, which gives us a source browser for all the Roslyn code. And there is source.net, which gives us a source browser for the BCL. And if we jump to that and want to navigate to the value type, to system.valuetype, we see that it implements equality for us and also get hash code. And both implementations basically have some caveats. So the equals implementation, there is a method invoked called can compare bits. And if this is true, a very fast version of equality will be invoked. However, if this is not true, we will have a look at when can compare bits is false, then reflection will be used. So we will at one time reflect into all the fields and then start compare them. And reflection is allocating memory on the heap, and it's not the fastest, so we will have a performance hit here. And also the get hash code, there's a little note here. So it says that the algorithm for returning the hash code is very complex and it would be rather expensive. So what the BCL in this version decided to only compare the first non-static field. So which is the number in our example. So all the other non-static fields, such as the text, are ignored in the default get hash code. And this is why we have a hash code collision. And this hash code collision now may cause severe performance issues. If you have a look at a benchmark, where this is the wrong benchmark. This is the right benchmark, yes. Where we have a read-only record struct, where the record is actually under the hood implementing both equality and get hash code for us, and a plain struct, which does not get any implementation, but uses the default implementation from the value type. And if we would put now both, we have hash sets, and we put, again, we do the very same thing. We put an element with 1, 1, and an element with 1 and 2. So with the default implementation, not only will we get a hash collision, because only the first non-static field is used for hash code, but also if we have a hash collision, that means equality is invoked. And equality will use now, since we have here a reference type. This is the second part that I wanted to show you. If we jump to the source code, let's go to GitHub. And if we search for this can compare bits, I think it's here. There is also an indicator. Can compare bits returns true if this value type does not contain a pointer. So our struct has a string, which is a reference type. So can compare bits will return false. It also, for example, returns false if a floating point number is involved, or if the struct is not tightly packed. If you have padding in the memory layout of the struct, and then we use reflection, which will be slow. So we will have a hash collision, and then equality is invoked, and this is now very slow. So if we have a look at the benchmark, we see that the explicit version below is rather fast, 7 nanoseconds, and no allocations. So this is the record struct. But the non-record struct, which uses the default implementation, now has 228 nanoseconds and allocates 184 bytes. And this is only the benchmark of an hash set with 2 elements in it. This grows dramatically if the hash set is bigger. So this could be a huge performance impact in hash sets or dictionaries if you use structs which do not overload equality. Now, I guess I gave the fix already away, turn it into a record struct, and then the C# 9, record struct C# 10, then the C# 10 compiler fixes it for us. But what if that didn't exist? Now we need to manually go ahead and override equals and override get hash code. And we always know it's the same implementation because we will be comparing all the fields. So we'll be going to number is number of the left side and the right side equal and text, and the same for hash code, combine the hash code. So it's always the same implementation. It's very tedious. And we could have a generator generate this pattern that we know ahead of time how it looks like to avoid reflection under the hood. So we don't have to implement tedious code, and also we get a huge performance benefit. And let's have a look at this generator. This is quite a bigger one, but I'll highlight the most interesting parts. So I'll start again with the iSource generator, where we register a syntax receiver. So we will be scoping for struct declarations that also have as a modifier the partial keyword. And then we go ask the semantic model to get the named, to get the type out of that. Here we see I'm actually using cancellation token.none because the syntax receiver doesn't supply a cancellation token. If we had a cancellation token, we should pass it. We should forward that to this method call. And then we ask the semantic model, we get the compilation, we grab the IEquotable interface and basically have a look at if this type does not implement IEquotable yet. Only if it does not implement it, we consider it a candidate because we intend to add this IEquotable and the implementation. Then we have a set of candidates with which we go to the execution phase of the generator, where we also here, we do some grouping. So I'll be grouping the structs in order to avoid possible duplicates because the user could have their struct already partially declared. So the user could do something like, there was the no, that's again the wrong benchmark. So the user could, for example, split this struct into two parts and have, so let me do this correctly, have the number in one part and have the text in the other, mark it as partial. But now the generator will get the myStruct twice in. So yeah, so this is why we have to merge them so we don't, otherwise we would generate it twice and then we have a name clash because yeah, we already generated the IEquotable implementation for the struct and then it would fail. So we do some grouping, we eliminate duplicates from the syntax analysis. And then we get all the members. Here in this example, I scope for properties. We should do for fields, but this makes it a little bit more easy. And then we generate the string. Again, auto-generated on top. I like to enable nullable scopes. I will be setting the namespace if this type is not in the global namespace, because if it's not in the global namespace, then we use the containing namespace. If it is in the global namespace, we shouldn't add any namespace declaration here. And then we can generate the partial struct. We implement IEquotable. We always put this generated code attribute on each of these methods. So we generate the equality operators. And this, we see this is the very pattern that we would hand implement ourselves. Then we override the get hash code, where I'll be using system hash code combine. We overload the, no, here it is. We overload the object-based equality and implement the equals from the IEquotable interface by comparing each member. So combining the results where we use the equality comparer and call the equals on that on both members of the left and the right hand side. What we also see here, I'm referring to the equality comparer, not directly, but via the global alias. So I'll be writing global : system collections generic. This is also a good practice to refer to types from the BCL through the global namespace. So the global alias because technically the user could implement their own system collections generic equality comparer, and then the generator would create potential code that would clash with user code, and then the compilation would fail. So if you're requiring a BCL type, it's a good idea to refer to these through the global alias. And when we're done, we add the source. And if we now, well, I already made this struct partial. So this is now subject for the generator. And we see that if I hit F12, we have 3 declarations of the struct, the one up here, the one down there, and the one from the generator. And we see this is what the generator creates. It implements iQuotable, all the operators, and so on and so forth. We have the get hash code implementation. We have the equals, which casts and forwards it to the strongly typed. And here we have all the equality comparers combined. And if we run the benchmarks now, well, I run them ahead of time. We see that now the implicit version, this is now the part that the generator is generating. It is a little bit slower. We are nanoseconds here because I'm using hash code, which involves a method invocation. So the version that the record struct C#10 feature is giving is slightly faster, but this is nanoseconds. But neither of them allocates. And so we not only fixed the hash code collisions, we also made equality fast because we have no more reflection involved. However, there is one issue with this generator. So the generator creates code, which is fast, but the generator itself is suffering from a problem. Let me add here as well, datetime.now to it. Let's build that. And if we have a look at what the generator now generates, where's the benchmark? Is this the right bench? No. Yes, it is. There it is. Putting this down here and having the test up there. Okay, so if I would change something in the struct, of course, the generator must run again because implementation will change. But if I change code somewhere else, for example, like I'll just put a, sorry, let me put this up here. Yeah, so there we go. There we go. So here we have the generated file. Here is the benchmark, which is the source for the generator. If I hit enter, we will see this time is increasing just momentarily. It's not because I gave the fix array. Sorry for that. Let me break it. Yes. All right. Now I hit enter. And we see that this time is updating. Although I'm not changing anything about the structs, again, the source generator is running and generating the very same thing over again, only this time changes. But yeah, so now we will use incremental generators to fix that. Now jumping to the incremental generator, this will look very similar, not the same, but similar. So with the incremental generator, instead of the syntax provider, we will now be using, the syntax receiver will be using a syntax provider. The syntax provider has basically 2 steps. It has a syntactic predicate, where we do the syntactic check. And we can also do some semantic transformation. So for the syntactic check, this is pretty much the same as we had in the syntax receiver. We scan for all the structs which are partial. And in the semantic transform, now we know that this node is the struct that we filtered up here. And we do again the checking here for if this I-quotable interface is already implemented. So we basically split it up in two. And then we have the first part of the pipeline. Now we do the filter, we check are there no nulls. Now we collect these. So we now have an immutable array of those I named type symbols. And we do the deduplication here. The implementation here, I basically put them into a hash set, and which now leaves all the duplicate structs out there. And then for the last step of the pipeline, we now do some transform. So what I do in this transform is basically filtering out all the interesting parts that the generator needs. So we grab the namespace, we grab the name, we get all the properties, and we put them into a separate, where do I have it? Into a separate structure that we'll be using. So we're not using this I named type symbol from Roslyn directly, but basically put it into a form that we need. And then we have in the register source output, we do the very same code. We have here, we generate, this is the very same code. And now if I would run it again, we still have the same problem that, so now let me jump to the correct files. Yes. That if we change a line, the generator would update again. Now it's changed. So we haven't fixed the problem because I intentionally left out the last part of this generator. The last step of the pipeline is that with intention, I put them into a separate type, into a separate structure that we can now apply a comparer with. So for each step of the pipeline, there is a with comparer where we can now use, actually, let me revert what I previously had. I'll be using a comparer that I built for this very struct that we have, which now compares that the namespace and the name of the struct that we filtered out is correct, or is the same, and also the properties, where we do a sequence equal over the properties. And now this generator is comparing at this. So actually the generator, we have several steps. We have 1, 2, 3, 4, 5, 6 steps of the pipeline. And for each step of the pipeline per default, this generator is using the default equality comparer to check, is this the same result that we had from the previous one? But we can override this default with a very explicit comparer. And now with the new comparer in place, if we put this code down here again and have the generated code up there, now we have this time here. And if I now start changing code, we see that this time will not update anymore, because at this last step, the generator will understand, hey, this is the very same input that I got in the previous run. I don't need to run the execute method again. So we will save a lot of string allocations that we would do to create the source code again. Unless, however, I would be changing the struct. So if I would go ahead and change, let's rename from number to number 1. Next. Now the time will soon change. Yeah, so it just changed because now actually the input from the previous one differs.
Stefan,
the input from this, yeah.
We got a question from Thomas Mutter. Thanks, Thomas. Is can or should I distinguish between local development and CI pipeline regarding generators?
I'll come to that in just 1 minute.
Okay.
Yes. Now in this step, we actually had to kind of generate again because the input changed, and we really needed to generate again because now we have number instead of number 1 instead of number. And now we set up the pipeline correctly, and we reduced the invocations. We utilized memorization of the incremental generator in order to get good performance in huge solutions as well. And this, now the question segues perfectly to the next part, to distinguish between local development and CI pipeline. So if we want, from a pipeline point of view, or basically, which is a .NET 1, there is no difference between an incremental generator or a source generator, because there is no driver. What the editor, what Visual Studio and Rider are using is a so-called generator driver, and this will be reused, and this does the caching and memorization. But if we just do a .NET build in a CI pipeline, there is no subsequent ones of this generator. There is only one, which means there is basically no difference. There is no pipeline to utilize. So incremental generators are only potentially faster if they're built up correctly in IDE scenarios, such as using it with Rider or Visual Studio. I think even I'm not sure about Visual Studio Code, for example, but I thought that perhaps the what's the name of the C# plugin? I forgot the name. Is also utilizing
OmniSharp.
Yes, OmniSharp. Yeah,
and it works. They have you can type and then generate in the background.
Oh, that's cool. Okay, so OmniSharp is also utilizing the generator driver, but yeah, from a Mio.NET build doesn't utilize that because there is only one. So the pipeline is basically useless for these scenarios.
Maybe Stefan, I think the question was even more general. I think Thomas wanted to know if there is a difference between local development and the CI pipeline. He was not asking about the difference between incremental and normal source generators. So just developing locally and running or building the code in the CI pipeline.
Okay. Well, there shouldn't.
Exactly.
There shouldn't, because okay. Thank you for that, Q, because this segues. This leads me back to the presentation. Excellent. Stuff is coming together to the best practices. One of the best practices is source generators should be deterministic, especially incremental generators, because if they're not deterministic, this pipeline in the IDE scenario wouldn't work. But they really should be deterministic. So with the same C# code and additional files and compilation settings with the same input, the generator should generate the very same output. So there shouldn't be any difference if I build it locally on a CI pipeline. Yeah. But what we do need to consider is basically the SDK that we are targeting. So if we're using, I guess now with .NET 7 on the horizon, if we would use the later Roslyn packages, I'm not sure at which version. Is this version 4.4 or 4.5, which will then only be compatible with .NET 7 SDK, we would exclude users of the .NET 6 SDK, which is a LTS support. So we need to keep that in mind of who's the target audience of our generator. And we should also keep in mind the language version that we generate. We're just putting out a C# string, but then the compiler basically compiles the generated code and the original code of the user together. And if the generator is creating C#11 code, but the user has set their project to C#10, this compilation may fail. So those are things to keep in mind when it comes to thinking about the target audience of this generator. Also, performance is super important. Up there, I list the best practices. Put auto-generated comment. It's great to have nullable enabled. Use the global alias. Apply the generated code attribute on the type if you're generating the entire type. If you are adding new members to a type, then to those members. And have the .g.cs or .generate.cs as a name. All of that tooling knows, okay, this is a generated code. Analyzers shouldn't run, or other stuff should be omitted because the user has no direct input. Testing is key. I actually do have for this generator, and we saw here, oops, there it is. I have a couple of tests in place, which now means we can also use code coverage. So if we run these, we will quickly see that. Perhaps I should mention that for testing, I'm using this package, which is also from Microsoft. Microsoft Code Analysis C# source generators testing.x unit. There is also an NUnit and a MS test variant of this package. And now if we have a look at the generator, okay, I have actually one test failing because I added some string, but we see now we get some gutter lines here, so we can analyze code coverage. We can also, since it's basically just library in a specific format, but it's just consuming a Roslyn package, and we could create a NuGet package out of that as well. We may utilize, for example, mutation testing. And I did have a mutation test one just before with striker.net. And if we look at this result, we see here is our incremental value type generator. And let's have a look at what I oversaw. What's an interesting takeaway? Yeah, so actually I have no test in place. So this, so mutation testing in this part changed the system I quotable string to an empty string, but no test was failing, which indicates that I do not have a unit test that checks that it doesn't implement equality if the interface is already there. So I totally missed that test case. And since it's basically just a library, we can do TDD mutation testing and have it built in a CI pipeline, build a NuGet package of this. So this is very convenient to build a project. And back to the presentation, if I find it, there it is. And yeah, so these are the best practices. If you want to get started, I built a template which contains a Roslyn analyzer template as well. So this is a template pack. You can get it by installing f0.templates. All the links are in the presentation. I'll sharing them in just a second. And this basically gives the project that I used for the second example, where we built this equatable generator. It gives all of that also with multi-targeting, and you can then build a NuGet package out of that almost right away. And I also have a couple of examples in this presentation if you want to have a look at what other people built with source generators. And I'm also linking to videos and blog posts with more infos about generators if you want to dive a little bit deeper into this topic. And here is now the QR code, which leads you to my socials and also the start of this presentation if you want to review it again. And all the source code is on GitHub. And now I'm having a look at the questions tab. And at least in the chat. So I believe we answered all the chat questions. Are there some Slido questions open? Before we jump into the expert round.
Yes, there are two. What are your 3 best practices or tips for source generators? That was 40 minutes ago, so maybe you answered that one. And what resources would you suggest to learn about source generators and to go deeper? I think you just answered that one, maybe also.
Perhaps I highlight one resource. So this is, I found this rather late actually, but I would have really embraced this if I found this earlier. There is a series called Learn Roslyn Now, which goes into good detail about how to analyze the syntax tree with LINQ, also highlights how the semantic model is working. There is enough, this is a bit of an older series, so this works well with building analyzers, for example, analyzers and code fixes. But with that series, you get a good understanding about the Roslin programming model and how the syntactic trees and the semantic models are built and used. And with that, you can then go on to the source generator journey, where we have, do I have it here? I don't have that here. Well, either have a look at some of the videos or also go to the source generator cookbook that Steve mentioned. I'm wondering, I have it linked somewhere. And also, since rather recently, for incremental generators, there wasn't really good documentation, but it has been added recently. Incremental generators. I have it linked somewhere in the presentation. I don't want to go find this now because there it is, which also graphically highlights how this, for example, how iSelect works between the value providers, how these boxes work, and also explain, where is it? Come on. I don't find it. The comparer, I can just, yeah. So the comparison, how this is work, how the pipeline is, how several steps of the pipeline are compared to each other in order to utilize memorization. Perhaps I should create a definite list of links, but they're all in the presentation if you want to go this path. So first make yourself more familiar with Roslin in general, and then dive a little bit deeper into source generators in particular.
Stefan,
Yep.
There
is another
question.
Jose, go ahead, please.
You can do it. From John Deep is, will source generators ever allow to change the code?
Well, I don't know, but I don't think so, because this is like in the, if you have a look at the generators cookbook, I think this is like in the very first section. This is one of the design decisions to have them additive only. As Steve mentioned, there is aspect-oriented programming, which we could utilize which is actually MetaLlama is built on Roslin, so it's possible. I'm not sure if source generators in that version, I don't know, but I could imagine that in that version, source generators won't be able to do it. Perhaps there will be in the future a different programming model built into the SDK or into the Roslin packages that enables it, but I don't think there is a current plan for that.
I believe back then the reason was that they had to introduce some C# keywords, especially for this case. I don't remember exactly what it was. I think in the very first versions, they had something where you could change, but I think it led to several other issues. So, and I believe extending the partial stuff, right? And this is, when I wrote generators, I didn't feel any limitation by just adding existing or additional code to the existing code. So, yeah. But I believe that there is something, if you are interested about this, you can actually find the things in the GitHub repo. And yeah, and I believe that was the reason, but I have to look it up there.
What's the craziest and wildest thing ever done with source generators? Well, what I see from my point of view, it's what Steve briefly showed in his session, the regex generator. Yeah. There's also a video from Nick Chapsas, who has a look at what the regex generator creates if you have the default email regex generated, and it's a lot of code. It's a lot of code. So I guess if you understand the regex, the regex generator, then you understand Roslin generators.
Problem is, to understand this one, you need to understand regex, right?
Ah, yes. Damn it.
That's why I like the comment at the top when it's telling you what the regex is actually doing in the generated code.
So I guess we are already in the phase of Ask the Experts. So I would like all the audience to give an applause here to Stefan. Thank you so much.
Thank you for having me. It was fun.
Yeah, it was great. I've learned a lot. I play a bit, but with the previous version, so there were no incremental generators, and now it looks a lot better, and I learned a few best practices here. It's pretty cool. And I will probably rewatch the session for any part that I may have missed.
There's also I linked it in my slides. There was a talk by Chris Sinkiewicz, and I'm really hard to pronounce his name, but a developer on the Roslyn platform, and he does a deep dive on incremental generators. And yeah, they took me some time to wrap my head around the pipeline approach. Yeah.
Now I'm afraid if it took you some time.
But once the penny drops, then it's amazing. It's worth it. It's worth the effort.
All right. By the way, I will ask you both if you can put your slides on the meetup event, so you have a way to add files or add a link to them, so you can perfectly drop them on your GitHub and put your GitHub there, a link to it. And if you have any link that you show, like the one just before, I'm not sure that's on your slides, but that would be really, really very good to have, because that's pure gold, having that picture with these boxes and arrows, all the workflow.
Yep. We have another question from Dario. Dario wrote, I'm personally still careful when to apply code generators, as maintenance efforts can get really expensive. What is your take on that? So, and he says, if you have a hammer, everything looks like a nail. That's true, right?
That is true. I see myself in that statement.
Yeah, I had a thing a few weeks ago where it was at work, something I went, yeah, we could use source generators for that. And then as I looked into it more, I just went, no, you can't. No, you can't. Because it was relying on some external data.
Mm-hmm.
So yeah, I tend to look at source generators as this nirvana of being able to solve a lot of problems, and it isn't. It has quite not a limited set of use cases, but a very specific set of use cases.
Yeah, for me, it's mostly sometimes you have, when you use T4 or another generation, I think, Steve, you mentioned CodeSmith, and I remembered that I was using it decades ago, or I don't know, 12, 13 years ago. And for me, the thing is, when you notice that you use CodeSmith or T4 or any other generation, and usually you have these additional steps, you generate additional code, and then you compile again, you include the generated code, you compile again. When you have these things where you need to compile again with the additional files, then it speaks clearly that a source generator might be the better approach, because you don't have that extra compilation, manual compilation step, and you even get the things on the fly while you type. And I believe with a new API of the incremental generators that Stefan showed now, it's also performant, and you don't have the issue that the IDE slows down. And maybe it works not only with Rider, but also with Visual Studio. I don't know. But yeah, I think so, right, Stefan?
It works with both, yeah.
Yeah.
I'm allowed to give an opinion. I think that it is on the contrary, right? Because all the maintenance is limited to the source generator, which can be a bit more complicated. But if this generates 1,000 files and you have an error, you fix it in one file and you have fixed it in the 1,000 files that it generates.
I think that comes back to, as Stefan was showing with the unit tests. If you've got really good unit tests around the generator, or you have a new scenario, then you can write your unit test, and therefore you test it in there, instead of, because when they first came out, I was debugging it using Visual Studio, and the caching of it, I was having to restart Visual Studio every couple of minutes, and it was a horrible experience.
When was that fixed?
So the caching, I think it still isn't actually fixed at the moment. But I was talking to Stefan just before we came on, and this is why he uses Rider. Because Stefan, you were saying that it's not a problem in Rider.
Yes. So in Rider, if I actually change the generator that I consume as a project reference and I rebuild, then the generator is loaded again. Yeah, but Visual Studio loads all the Roslyn components on startup. So yeah, restart is in order in Visual Studio.
So we can say that using Rider is the best practice for source generation.
Not necessarily. If you debug through Visual Studio, if you have unit tests, actually I started with Visual Studio developing generators. I'm now using Rider because of the live coding scenario, so I don't have to switch doing live coding. But when I develop, I have the unit test, so I don't care if Visual Studio has it loaded or not. I run it through the unit test, and so it to me it doesn't really matter. And you can also debug them through the unit test. And in my opinion, the unit test is even more scoped because I potentially don't have a big project. I only put the string. The unit test has two inputs: the user code as a string and the expected output as a string. So we have a very specific scoped scenario, which also then makes debugging way simpler because I reduce it to a very limited scope.
I believe when you build one, test-driven development is really the way to go, that you write your unit tests and then build up the generator. And I noticed these issues also at the beginning. I believe it was even when you restarted Visual Studio, it was even caching back then if you didn't update the assembly version attribute or something like that. And
yeah, I mean, that's why, like in my talk, I was saying I was dropping down to the command line and just doing .NET build.
Yeah.
And not using Visual Studio as a debugger, other than creating a build profile where I sort of said, if the debugger's not attached, then hit a breakpoint. But you need to just do a particular build profile because you don't want it doing every time it compiles.
Yeah, I had to smile, Steve, when you showed the debugger attach code, because I did this also at the beginning.
Yeah.
And then I didn't use the NuGet package for the testing. It was not available back then.
No.
And it was a bit of hassle to find out how to load in the assemblies and all the stuff to get the unit tests working. But I think once you have set this up, then you don't have to care if the IDE is caching something. You can focus on your tests, and I believe that's the best way to write them. But Visual Studio might optimize things maybe in the future, but let's see.
Just saying on your MVVM Lite, which is also a question that you responded in the chat from John D, which I thought, oh, that's for you, and you already have replied. I was keeping an eye on your MVVM source generation library, Thomas, and I really like the way you implemented the class builder. The only thing
the string builder wrapper.
Yeah.
With the indentation,
What I was missing is the indentation string, this that you can automatically indent. I didn't know that this existed. I just learned it today from Steve and Stefan.
Yeah.
But I think this having something like the class builder is quite, to me, or it looks like a best practice.
Yeah, it really depends, I think, how complex the code is that you generate. Sometimes you can use template strings to get everything done, and sometimes you notice you have to build some loops around it, and then suddenly you end up with those padding left strings in your code. and that, so this was the case in my MVVM library too. But I have to migrate it to the new API. So this is something that is on my list.
Mm-hmm.
And I noticed it's not really just change the API, it's a different pattern. So there is a bit of work to do.
But also not too well, I guess a little bit of restructuring to make memorization
Yes,
possible.
exactly.
But the core logic of creating the string
That should be the same.
mostly
Also,
untouched, yeah.
analyzing the syntax, right? It should be very similar.
So it's moving a lot of code around. Yeah.
Yes.
There's a question here from Alex. I wonder if you could place all the props that want change notifications in a name region. Example, hash region observable, and then check the tree for this region.
I'm not sure if the region is in the. We need to check if it's really in the syntax. It should be, I guess.
Yes,
I guess it would be in the trivia bit, wouldn't it?
It's done. I think the preprocessor directive, I think they're called structured trivia. So you can. I don't think you get them as a node in the syntax receiver. So I guess you have to scan in the syntax tree. You have to scan it manually, either via the syntax tree, or there's also a type called the syntax walker, where you can then override specific methods on interesting stuff and then filter the candidates. But this is a bit more of a manual approach, I think. Yeah, but it's definitely possible.
This goes also a bit in the direction of the question from John, who was asking if there is another smarter way than using attributes to generate this iNotify property changed stuff. I think, John, you could also check if the class implements a base class. Maybe if you have a view model, it might inherit from view model base or something, and you could just check on that one and generate the whole iNotify property changed boilerplate.
Could also be a comment, or
a comment,
or having the type end in the specific name. Now, this may cause other problems, but
once you get into magic strings, it all starts to get a bit tricky.
But Microsoft seems to choose the attribute way. So I think all of the generators, isn't it? The JSON, the regex, the logging generators, all of them are based on attributes. Yeah.
Or another approach could be to write your own domain-specific language and put everything on the mapping on iNotify property in one file. And
then include this as an additional additional file. If I understand it correctly.
Putting everything together, right?
There was a question about custom MS build tasks. Any plans for presentation on how to write custom MS build tasks, how properties and targets, etc. work? MS build, that's a whole different kettle of fish. I can't think of one, though there is a good book. Bear with me 1 second.
By the way, before anybody asks, Michael had a big migraine today, so it got worse, so he had to leave.
Okay. I have this every half year, and before I could never believe that people have to go when they had a headache, but now I know actually what it means. So
when it happens, it really can hurt a lot.
Yeah. I think he should have turned from vertical to horizontal.
Steve,
it's a rather old book, but I don't know whether MS Build Trickery. But I think it's quite an old book now, which goes back to MS Build in framework days. But I think a lot of it sort of still applies in sort of modern MS Build. Because I was looking at that to see how, because one of the things we haven't covered, we've talked about looking at C# code, but sometimes you want to look at properties inside the actual CS proj file as well, and that you do have to jump through quite a few hoops through that. I've forgotten that. Stefan, have you come across it before? I'm just trying to remember. There's a very specific thing you have to do to get, and you have to declare the properties in your CS proj file to be able to get to them. Because I can't remember it off the top of my head.
Per default, just like additional files, per default, source generators don't just get additional files as an input. So you have to specifically mark additional files as input. And that's the same with MS Build properties.
Yeah, I did respond to a tweet a couple of months. Let me bring up Twitter and see if I can find the thing I looked at.
I always forget it as well. It's like make Roslyn visible something.
Just trying to remember it now. Because I responded a couple of months ago to someone asking on Twitter.
Compiler visible property.
That's it, yeah. Because I think one of the things I was looking at was trying to see if you could find out the root namespace that was declared in the CS proj. So not necessarily. So if for example you're using additional files, as we were saying, and you want to generate some code, you want to know what namespace to generate code into. And I think I was trying to work out how I could get to the root namespace property inside MS Build, the CS proj file, to be able to get that root namespace out and then put that namespace inside my generated code. And it was quite a few hurdles to get to it.
Yeah, so you mark the property as compiler visible, and then you can, is it through the compilation? No, there is an analyzer config options. Yeah. And through the analyzer config options, you can then read the values of those compiler visible properties. And yeah, I guess.
Okay, that's something which is interesting. I would be interested in knowing more about that, because that can save a big problem. What if you have a project that generates code, right? And you have several projects that use this one. Usually what you do is you generate them in the namespace of the project that generates code, right? But then you can generate duplicates because maybe you want something that is a scope for the assembly which is using that. I don't know if it's clear what I say, but I hope it makes sense. So I believe that if you have a multi-project solution, which usually is the case, you need to do that.
Yeah.
Up was a question from Eric regarding the inserting code between region trivia with Roslyn, a Stack Overflow link. This is about the C# syntax rewriter. And as far as I know, this creates just a separate syntax tree, so it does not modify the existing one, as that one is immutable. And I think the post is already a few years old. The C# syntax rewriter, I don't know exactly when it was introduced, but it's there a while.
And this, for example, could be used in a code fix provider, for example, or in a code refactoring. But yeah, not really in a source generator, because you cannot exchange existing code.
Yeah, that's a good point. The API for analyzers and for generators is actually the same, right? So
yeah.
Hi, Eric, by the way, I saw you, but I did not greet you. So hope you are okay.
One of the things that I don't think Stefan or I really touched on is the use of diagnostics to be able to provide warnings for the stuff that you're doing when you're running your source generator. Did you have a bit on that in your slides that we skipped, Stefan?
No, I don't. And I forgot to mention it.
But one of the things you can do is, I think you touched on the unit test that isn't covered, where there was a namespace, not a namespace, you were looking for a particular type. So that what you can do is you can generate compiler warnings and compiler errors while the source generator is running, that sort of says, I'm expecting a particular type or namespace to be present, and it's not present. So therefore, I can't generate the code.
Perhaps I briefly show you. So you could next to the context at source, there's also context.report diagnostic, and with that we can create a diagnostic, and this diagnostic is a info, a warning, or could also be an error, and we pass a location. The location, for example, of the syntax node that we want to get the squigglies on. And so we could also generate warnings and errors to guide the user of making the code generatable.
Yeah.
There is a comment from John D. Instead of attributes, I was thinking of similar approach on how EF works when setting entity model mapping. And he put kind of a code example in the comments, like view model builder, punct observe, the lambda with X name. Yeah, like a meta chaining. I think that's how you call this kind of syntax. I like it because it's, well, I love Fluent syntax. It makes everything a lot clearer. So whenever I build something, I try to use it like that. Like, for example, a builder, right, pattern, where you can meta chain everything and at the end you build.
And the framework is using a lot of reflection emit under the hood, right?
Yeah. I don't know. I haven't been keeping up with EF7, whether they're starting to move to source generation. EF core 7. I haven't been keeping up with that.
But I believe the whole link expression compile stuff is reflection emit based.
Yeah.
So, yeah, but
well, they have both advantages and disadvantages. What I learned, or what I got aware of recently, is that if you reflection emit and link expressions, if you need to generate code at runtime, then that's the perfect choice, because compile time is quite early. However, if you need AOT compilation, I think Apple platforms don't allow just-in-time compilation. So then only source generators would be the only solution, since you can't generate code on the fly.
yeah, exactly. I think that's the difference, right? Source generators are compilation code generators, and reflection emit is runtime code generator.
Yeah. I think that's been a driver behind regex now getting some source generator goodness.
Yeah. And by the way, we are also all source generators.
The input is caffeine.
Exactly.
So John D say that EF has not yet moved to source generation.
Yeah, I think for the reasons the guys were saying about sort of reflection emit and being able to understand link expressions, I think source generators, because it's all based around syntax, I think because link is sort of so flexible, I think it would be really quite hard to write stuff that actually passes that. But given that they've done it with reflection emit, presumably it must be possible in some way.
But I do need connection to the database to make sense of it. So there is runtime involved. So
yeah.
I guess this is not really source generator solvable, or ahead of time solvable. Perhaps for some parts, yeah.
What's for you the most powerful feature? Or what do you think it can be the most powerful if properly used?
I mean, for me, I think it's wherever you've been using reflection, not reflection emit, but reflection to inspect code at runtime. I think using source generators to do that at compile time. So, for example, Andrew Locke on his blog, he's got a good example of being able to do toString on. So say you've got an enum and you want to be able to bind the string values to a drop-down box, for example. There's awful lot of reflection going on with that. Whereas if you've got a source code generator that can generate a class that can say, here's the string versions of that and how they bind to the enum values, that gives you a massive performance boost over using reflection at runtime. So that's one of the key things I think source generators give you, is we're moving more and more away from this runtime reflection.
And if I recall correctly, it's not only faster, it's also saving allocations. The source generator version is 0 alloc and a heap allocation, and the default enum to string allocates through, because it's using reflection, allocates a little bit. So which adds up if invoked many times. Yeah.
One of my favorite things was I went to a talk, but I think it was Clifford Geertz, and he sort of said, we've only got so many keystrokes in our lifetime, so we should save our keystrokes. That's where source generators help us. Saving our keystrokes.
What is the craziest thing you have done with source generators? This question is for all of you, Stefan, Steve, and Thomas, and everybody in the room, if you want to respond to it as well.
I wouldn't say craziest, but the most ambitious thing I was doing was, when first starting out with source code generators, what I wanted to do was be able to define some classes just using some JSON, just sort of saying, I've got these properties that are sort of string, integer, and what have you. And I wanted to be able to say, generate them in multiple places. So it was sort of effectively write once, generate many. And once we started on it, it seemed to go okay. But then when you started having nested types, things started to unravel a bit, and you went down a bit of a rabbit hole on that. So it's fine if you've got some very basic POCOs that just have the sort of out the box types. So string, int, decimal, and what have you. But once starting to get into sort of custom types, and then you had to sort of say, where does that custom type, what namespace is it from? How do I address that namespace? The other thing that sort of was interesting was, if you wanted to use, say, Newtonsoft JSON to deserialize the JSON, trying to get references to other NuGet packages from within a source code generator NuGet package starts to become quite complicated. I don't know whether you guys have heard that experience with that.
Yeah, so for my previous company, we had a source generator. We had a Roslyn component which required a package. Yeah, there is some special syntax you need to take, and this needs to be, because the dependency needs to be packed in the package itself.
Yeah.
So it's not a transitive dependency.
Yeah,
that's a bit. I think there is an issue somewhere on GitHub to make this experience more easy, but it requires a couple of MS build properties to get it right. Yeah, that's crazy. Yeah.
yeah.
The craziest thing. Well, it's not building a generator per se, but for me, it's building
Craziest thing is the code you type that you could generate, right?
Could you come again, please?
The code that you still type that you could actually generate. That's actually the crazy thing.
Back to saving keystrokes.
Yeah.
Yes.
Yeah.
Yeah.
Yeah, I believe the important, and I like this with your 2 sessions. It was really a great, fantastic overview at the beginning and then a deep dive. And I think the important part is to really recognize these situations where you could use a source generator, right? That's the first step. You do something and you are in your work, and at some point you must recognize, hey, actually I could generate that whole part. And I think this is the important point that you have to come to. And for me, I think it was at the beginning a bit a hurdle. I found it not quite straightforward to implement the first one, but I believe we get better and better examples, and the documentation is also getting better. Yeah. So Sorry, Stefan. Now I interrupted you on the hardest part.
Don't worry about it. Yeah,
Or
documentation
most
indeed
crazy
is
part.
documentation is getting better. Yeah.
I'm sure I saw. I think it was one of the things that Microsoft put out on one of their community stand-ups, that they're now starting to focus on giving source generators a lot more love on the documentation side.
Yeah.
Because as you said, Thomas, the early days trying to work, you'd hit a problem and there was nowhere to go.
Exactly.
Other than having a look at how Microsoft built it in their JSON and logging generators. Yeah.
Yeah. But this was back in the .NET 5 days, before Microsoft actually started writing their own ones.
Oh, that's right, yeah.
And that's when the source code generator cookbook and the I've forgotten the name of the website that's got the various examples, going, oh, okay, right, I see how to do that now.
I once did something very crazy, but it was using reflection. So I was in the typical project where there is no developer, there is a code that fails, and we have like 2 to 3 months to completely test something that doesn't have a single test, right? And I built a reflection-based attribute system that was testing all the DTOs or elements in the database, because they were having kind of a collision system with the transactions. So I created like a system that try out everything with all the DTOs, trying to save and create conflicts dynamically through reflection. It took a lot of time finally, but it worked.
Yeah.
So the only thing or changes I needed to add is to add the attributes.
One of the things it's already code generated, but in my part of the talk, I talked about the Open API reference. Now, behind the scenes, what's going off is that's going off and using NSWAG's code generator behind the scenes. Now, whether there's any plans for that eventually to use what the sort of kind of source generators that we're talking about, that'd be an interesting avenue. But I know the Microsoft Graph team are also working on a code generator for Open API as well. So whether those streams will actually eventually come into sort of a Roslyn source code generator, I don't know.
But the question is if it's a good idea to download things like Open API specification from the internet during compilation.
Well, the approach that currently does is you download the Swagger JSON or YAML down once, rather than you pull it down and save it as part of your project. So it's always a local file, not going out over the internet to go and get the API definition.
Because we have the thing that in our Git repos, we have a lot of T4 templates hanging around, but most usage of these T4 templates is downloading some information, for example, from an SQL database and generate code from it. For example, enums or view models or whatever stuff.
Yeah.
And I always was asking myself, is it a good idea to migrate things like that to source generators? And I don't think this is a good idea.
As I was sort of saying in mine, anything that's got any sort of IO, be it network or database, I think those would need to sort of stay in T4 as a design time thing, that you run your design time tool, generate the code. You wouldn't want that as part of the because there was a question earlier about the CI pipeline. You wouldn't want your CI pipeline going off and doing IO to a database, because what happens if your build server hasn't got a connection to that database? What about you start worrying about credentials? It's a whole nasty situation going on.
I guess this also shows in the API. The other Roslyn components, such as analyzers and code fixes, most of them have async overloads and basic interfaces to task returning methods to implement. But the source and the incremental generators, they are all sync. So it's encouraged not to do IO. Yeah.
The John's comment about we need an AI source code generator from Jira tasks. We're starting to move towards that with Copilot because it's quite frightening that it can start to understand remarks, just sort of remarks, and generate code from the remarks. That's when it's starting to get quite scary. But one of my concerns about Copilot is that given that it uses a load of open source repos as its source, how many bad practices is it copying from those repos and introducing into your code? That's my concern about things like Copilot.
It's like with the stock market. In the long term, everything should get better.
Yeah. Eventual consistency.
Yes.
I had recently a discussion with a friend of mine that AI generators are not perhaps the best for education, because now learner of a new language now becomes depending on the tool that generates the code and not necessarily fully understanding what the code is actually doing that has been generated. Well, okay, that also applies to copy pasting from Stack Overflow, so I guess that's the same.
Yeah, but that's actually a great point.
Just cutting out the middleman.
Yeah. Mm-hmm.
A decade ago, I had a customer in a WPF training, and the person was turning off everything in Visual Studio, IntelliSense and everything. So it was actually like using Notepad. And I said, why are you doing this? And they said, yeah, you know, if Visual Studio tells me everything, I don't learn it. And yeah, and so I believe it's a similar thing right now that we have again. And I have seen people writing stuff that once a person wrote an Oracle connection string, if you know this one, with all the parentheses out of their heads, and I was impressed. How can you even memorize this? But sometimes this happens, and maybe we are just at a point where we think we don't believe it, but I think it's a tool that maybe we get used to it, and in a few years it's just normal. Why should you work without it if it makes you much faster getting your stuff done?
Yeah, I mean, but one example of where I think Copilot, reading from so many open source, is how many places is iDisposable things not being disposed?
Yeah, that's true.
Because does it detect that something implements iDisposable and it's not putting in either the dispose at the end or wrapping it in a using statement?
Or for me, it's implementing the dispose pattern correctly in the first place. I think I always do it wrong.
Yeah. Now that is where a Roslyn source generator, if you had an attribute sort of says, well, even if just the fact that it says it's going to implement iDisposable, you could have a Roslyn generator that sort of does the smarts on doing that properly.
I think I'm being nerd snapped right now. Yep.
In my opinion, this is also good learning source for new programmers. So all these analyzer hints guide people to doing things right. I mean, if you have no idea how to that you have to do something like iDispose it correctly, how should you know?
Well, certainly, but things like resharpers analyzers. When I was moving into sort of C#9 and C#10, and it's telling you, have you thought about using this new pattern matching thing to do your if statement and stuff like that? I find the analyzers a good way of learning all the new techniques.
Yeah, absolutely.
Yeah, I can't even count how many for each loops I transformed into link statements with resharper at the beginning when link came out, right?
Yeah.
It was not always better, but yeah.
It's true.
Well, but you learn how to do things in a different way.
Yeah, absolutely.
Hello, everybody. I'm a little late to the party. I've been listening in off and on. I had to go cook dinner. I was away from my PC, but great sessions. So I'm finally have some free time now to be at the desk and join the conversation. Am I allowed to ask a couple of questions?
Yeah.
Sure, go ahead.
So how do you guys deal with the the fact that these source generators are limited to .NET Standard 2.0, right? And if you're so two questions there, like source generators being able to target later frameworks themselves, and secondly, when you're generating code in within a host project, how do you know what version of C# it's using, right? So you kind of have to generate different code for depending on if the host project is allowing C# 9 or 8 or 10. Have you kind of dealt with those sort of challenges and come up with any solutions for that?
In one project, I went a little bit overboard and I wanted to create all the language versions. So in the source generator, you get the parse options, and the parse options contain information with which language and also with which language version this project was compiled at. So I then basically had if-elses for C#1, C#3, so everything. But this was a bit too much. Now I think choosing a sensible language version, for example, C# 7.3, which I guess has the broadest reach, because that also still includes .NET Framework as well, is sensible. And then if you need a newer language feature, then have some if the consumer is having a higher language version of the compiler, then using some newer features to get some more performance out of the implementation, I guess is at least my current approach now.
Yeah.
So isn't kind of like the sort of the downside of that is that you have to kind of go to some lowest common denominator again of the C# version, right?
Unless you know your consumer. If it's internal in the company, in your team, and everybody is on C# 11, then generate C# 11. But if the possible consumers is the world, okay. Yeah.
I think that comes back to the diagnostic thing where you could do a check at the start that sort of says what version of C# is the consuming project targeting. And if it's something that you don't support, you can throw up an error or a warning straight away that sort of says, I'm not able to generate source code for that version of C#.
Right, but that would be a shame, right? I mean, so
but, yeah.
But
I think unless you're like Stefan and want to cover every single scenario, there's only so much time you can dedicate to writers. I think it comes down to Stefan. If you know your audience is your internal one, then you can sort of say, I have this common denominator, or we only target C# 10, C# 11, what have you. If you're writing NuGet packages for public consumption, then you've got to put a lot more thought into it.
Right.
Yeah, but it's a good point. I thought also a lot about this, and I thought maybe one day we should have file scoped C# versions, because we have the same with the nullable attributes, and if we would have that, it would actually be possible to have just these files with a newer version and the rest of the project with the devs version that is consuming the generator. I don't know what this would mean for the compiler, might be much more complex, but
yeah,
it might go down the route of Webpack and JavaScript, right? Where
exactly.
You kind of are generating C# 10, and then there's an intermediate thing that's generating, downgrading it to.
Because I mean, we've seen things like the nullable types where if you're on, when did they come in? Was it C# 8?
9
types. But then if you had an earlier version, you could use a NuGet package to bring in nullable types to an earlier version. So then you'd have lots of if pragma, if defs, and what have you, that sort of saying, if I'm targeting this, if I'm not targeting that, and then it comes back to the complications that we were talking about earlier about bringing in other NuGet packages into your NuGet package as well.
Right. I mean, there are some sort of decompilers. I think they desugar down back to C# 1.0.
Yeah.
I wonder if those sort of desugaring, create the C# source code are open source projects that you can leverage, where at least your source generator from a maintenance point of view, you're just generating C# 10, right, the latest version. Then based on the project that you're actually targeting, it just kind of generates very ugly desugared stuff. But it's kind of going into I think down the same road as JavaScript and Webpack kind of thing.
It's like TypeScript. transpiling down to the
Yeah.
JavaScript versions. Yeah.
Like a transpiler for C#, right?
Yeah.
I don't think there's anything out there like that.
But also, the other thing is, if you've got to consider all these different versions, and you've got lots of sort of different paths your source generator can go down. Your source generator is starting to go slower, which is going to slow down the IDE as well.
Yeah.
And you won't have people thanking you. So if they're on sort of C#10, and you're trying to account for someone who's on C#1, then in fact, that said.
Well, I meant that, I mean, you'd only transpile it down if you'd find out that the target project was not on 10, right?
Yeah.
So, you know, but at least it reduces your own maintenance in terms of thinking of all those versions.
Mm.
Especially if you're using in different projects and solutions that are on different versions. But there's also the flip side about the source generator itself not wanting to target 2.0, because you know, if you want to target 6.0 or 7.0, then you kind of are lost in time with that. So one way out of that seems to be to run it out of process now with all the performance caveats of that. But then that would kind of liberate you from Visual Studio mandating 2.0, right? And I was wondering if there's out of process source generator as an open source project, somebody's done that, or anybody thought about that? Because it also solves the problem of, I think, what you guys were talking about earlier. I was just kind of listening in, but I was in the kitchen, around dependency on packages, right? External packages is also quite painful.
Yeah.
So if you want to, you know, depend on some Newtonsoft version or some other, you know, other kind of packages, which is not tied to all the other things that are loaded in that sort of whatever context of Roslyn, then the best thing is to have kind of a very lightweight source generator that's just sitting in and proxying over to the out of process one, so that when it kind of generates the source code, just streams it down into that one. And I don't know, something anybody's heard about something like that?
I have a bit of a déjà vu. There might be a discussion going on solving that net standard 2 limitation similarly somewhere, but I couldn't recall where. But I guess this is thought about, yeah. Because the feature that I'm missing is default. No, what's the string interpolation handlers? Because I do use a lot of string string interpolation to create the C# string, and this is super awesome with .NET 6 with the string interpolation handlers. But in a standard, I don't have them available, so that would be sweet.
Because also, I think, because we talked about sort of like the new file scope access and what have you. I think so. Some things are dependent, or you can make changes to the language without having to make changes to the runtime, whereas other things require a change to the .NET runtime, not runtime, but BCL. I mean, not runtime. And that's when it starts getting a bit more tricky. I don't know how they're addressing that with these C#11 changes.
Yeah, because I think static abstract members require .NET 7, and then yeah. There's I mean, even the C# compiler runs out of process. You know, so it actually when you look at, there's a .NET shutdown command that actually shuts down the C# and the VB compilers. They run out of process in any case from Visual Studio. And there's the Uno platform project has a source generator that does the out of process piece.
Oh, okay.
But it's very unfortunate. It's just not a nicely packaged NuGet project that you can just use and then liberate yourself from that. So I was hoping somebody over here knew about something else.
Not yet, I'm afraid.
That guy took the same source code as the C# compiler for hosting itself out of process, and it uses kind of name pipes to do communication, but it's a bit of an infrastructure setup. But yeah.
All right, gentlemen, I would not submit our expert panel too much. So I think you can accept like one or two more questions because it's already 9:10, and probably everybody here still needs to have dinner.
I'm still an hour behind. I'm an hour behind you, so it's still only really.
Cool. Okay. So no more questions then. And again, we are still some, but I give you an applause here. Thank you so much. It was fantastic. Really cool. I will watch it twice probably. Thanks, Stefan, Steve, Thomas, Michael as well.
Pleasure.
And everybody that came here.